Hi there, I am Mohammed Amin Mukhtari, founder of pycad, PhD candidate in computer vision, and your guide to the exciting world of medical imaging with Python. For the past 2 years, I have immersed myself in the field of medical imaging, from writing in depth blogs and creating educational courses to consulting and mentoring in this dynamic field. Our journey is divided into three comprehensive sessions. We will start from the basics of Python, then dive deep into specific Python libraries for medical imaging, and finally, we will explore data pre-processing for medical imaging model training with MONAI framework. Whether you are a student, a researcher, or a practicing professional, this course is designed to revolutionize your approach to medical imaging. It is not just about enhancing your skill set, it is about contributing to a healthcare revolution and making a tangible impact on patient care. So the first thing that we will do is to create a Conda environment. Why we are using Conda? So as I told you, we need always to have a virtual environment where we install all the packages that we need for our Python codes. For now, you don't need to care about these, what does it mean package and all these things, because we are still writing basic Python code where we don't need any package. But for the best practices, we need always to start our project with a virtual environment. For now we are using a conda environment, but it is the same thing. So after installing conda, when you open your command prompt, you come here and there is a command line that you put to create a new conda environment. So this command line is conda create and then dash n or dash name, and then you make a space and you give the name to the environment that you want to create. So for example, let's call it medical imaging for Python, or let's reverse it like Python for medical imaging, something like this. Python for medical imaging, just something like this. But you need always to put like your name that you will recognize for your project and all these things. For now, we are just putting it like this. I don't want to create a very long. I don't want to give this environment a very long name. But if you want to specify like the whole name, you can just put it Python, then underscore for medical imaging, something like this. Let's just put it like this, okay? So after doing this, if you just click enter, it will create a new virtual environment and it will install Python inside that virtual environment. But the Python version that will be installed is like the latest version in this conda that you have created. So if you don't need to specify the Python version that you need for your code, then you just need to click enter. But if you really need a specific version of Python, so let's say you are using a package that will need a specific version of Python, then you need to specify the version of Python. So to do that, let's just put Python and then equal, and then you put the version. So for example, 3.8, something like this, okay? Then let's press enter. Okay, let's press Y for yes. Wait a little bit. Yeah, and now the environment has been created. So when you want to use this virtual environment, you need to activate it, because till now the virtual environment has been created, but we are not using it. How do you know if the virtual environment is created or if you are inside the virtual environment? You need to see here, like inside the parentheses, you need to see the name of your virtual environment. And since it is written here, base means that you are only on the base environment and you didn't activate your virtual or conda environment that you created. So to activate it, it is already given here, or you can just write conda activate and then the name of your environment. So Python medical imaging, okay? And then press enter. Yeah, I think I forgot this for medical imaging. Okay, so now you can see that it has been created, it has been activated, sorry. So now you are inside the virtual environment. So if you click Python, now you see that you have the Python 3.8, which we used when we created the virtual environment. Now you have this environment created with the exact Python version that you needed, and everything is working well. So now we can start coding and start putting some lines of code so that you will get familiar with Python. And after that, we can go with some advanced things with medical imaging. So see you. And now, after that you created and activated your Conda environment, we can start writing some code. But to write a code, we need always not always, but like to write a proper code, we need to have a text editor. So there are a lot of text editors that you can use. Some of them are like by default that doesn't have any features that help you for coding, and there are other text editors that like have a lot of plugins that can help you, and everyone can choose the best text editor for him. So for me, I use always VS Code. I am using it for more than 3 years, and I always see that it is the best text editor for Python especially, and I think it is better or a good text editor for other programming languages. But as I told you, you can choose any text editor that you want. But for this course, I am going to use the VS Code. Okay. So after that, you have installed it. To open it, you can either click here on VS Code, search in the search bar, or once you are, because why I am showing you the second way, which is opening it from the terminal or from the command prompt here. This will help you to directly open the VS Code with the exact Conda environment that you have. Because if you just open it from here, you need after that to select the Conda environment to be used for your projects. But if you open it directly here from the terminal, the Conda environment will be directly used. But I will show you both ways. So here to open it, you just need to type code and then press enter. Then VS Code will be opened. Okay. So now I have already created a folder which has 2 files. I will talk about them just in a few seconds. But here, when you are in your in VS Code and you have created either main.py or you have created a file.py or file.ipnb, which I will discuss now. Here you can select which environment that you want to use. Okay, so for Python there are 2 types of files. There is the .py, which is .python, like a normal Python file, and there is IPYNB, which is for Jupyter Notebook files. So I will show you when we use Python file, a normal Python file, and when we use the Jupyter Notebook file. But after that, you can choose any one you want for your project. Most of the time, you will use the .py file, because Jupyter Notebook files, we use them most of the time for the education, or if you are just creating a small project or something like this. But for all the advanced projects or anything that you want to share with your company or something like this, you always need to create .py files, because you can run them directly and you can call them from from the terminal and all these things. But when you are using Jupyter Notebook, you will see that it is different than using a normal Python file. But we will test both of them and you will see what I am trying to say here. But the thing that you need to know is when you want to use Jupyter Notebook file, which is this one, for example, in VS Code, you need to install an extension before that. So to install any extension in VS Code, you need to come here in extensions, and here in the search bar, you choose any extension you want. So for example, for Jupyter Notebook, you can just put Jupyter Notebook and just put Jupyter and it will be here. So this is the best extension. You will find that there are a lot of extensions, but this is the most used extension. You see that it is downloaded by 63 million people. So you see that you can trust it, and it is from Microsoft. So don't worry, don't even worry about this. So you can just install it here. For now, for me, I have already installed it. So you need to install it, and it will be enabled directly, and you can use it. Because if you don't install it, these type of files, which are .ipynb, which is Jupyter Notebook file, it won't be recognized in VS Code. So you need to install that extension. But if you think that you will not need to use Jupyter Notebook file, that you don't need to install it either. Okay. So here, let's talk about both of them. The thing here, the difference between this normal .py file and the Jupyter Notebook file, which is Here, if I write any code, I cannot like run, let's say for example, line 1, and we have line 2, for example, and we have line 3. We have 3 lines of code or 3 pieces of code. Okay, so if I want to run the code, you should run directly either here on in this button to run the code, or you can run it from the terminal. But what happened, you will directly run the whole code at the same time. You will not just run the line 1 and then when you want, you run the line 2 and the line 3. But if you run the code, everything will be run directly. But the difference here in Jupyter Notebook, you can run like each piece of code independent than the other. When I say independent, it doesn't mean that the code that will be written in the cell, because here you will use a lot of cells, as you can see. So if you write a code here, so let's say code 1 or code 2, and here we have code 1, and here we have code 3. Okay, so if you run the code 2, this doesn't mean that it won't be recognized in the code 1 and code 3. But the thing, if you run this one, you will get results only for this code 2 cell. You will not run the code 1, code 2, and code 3. Okay, this is what is the advantage of using Jupyter Notebooks. You don't need to run the whole code, and while you need only a small part. So if you are testing a specific function, so you can put that function inside the cell and you run only the cell, you test it, you see the output and all these things. So this will help you when debugging your code. But once you have a whole project and you want to share with people, something like this, it is not recommended to use Jupyter Notebook files, because they are only for education or for debugging if you want, but it can't be used for production files or something like this. Okay, so this is the difference between a file like main.py and Jupyter Notebook file. For the course, most of the time we are going to use Jupyter Notebook file, because it will be easier for us to explain how the each part of the Python code will work. But of course, everything that we will run here can be run in a normal py file. Okay, so let me just delete this one. And now, before completing this, I just wanted to specify the thing. Like, you remember when we opened VS Code here from the command line, I told you that there are 2 ways to choose the virtual environment. Either when you open the file from here, it will be chosen automatically. But if you open VS Code from here, like from the UI, and then you may think that your VS Code project is not selecting the proper conda environment. So if you are in this case, what you can do, you just need to come here in the bottom, you can see here, and you click on this and you will see all the environments that are available here. But for now, you see, but that automatically it has selected Python for medical imaging. So automatically it has been created, it has been chosen. But for your case, if you see that it is not selecting the exact environment, so you can just scroll here and find your environment and then select it. Okay, and the same thing for the Jupyter Notebook file. What can happen? You need to select the kernel. So when you click, if you don't click on select the kernel, once you run the first cell, this window will be popped up. So don't worry about that. But you need to click on this Python environment, and then you need to choose which environment you want to use. For us, it is like Python for medical imaging environment. Okay, so this is the kernel, and that will be used for this project. But if you want to change it or select another environment, you just need to click here and then click here and here and select another kernel Python environment, and you choose which Python environment you want, conda environment or normal environment you want to use for your project. Okay, so let's delete this and this. Now you see that here how to open the how are the different types of Python files that you can use, either normal Python or Jupyter Notebook file. Now let me just show you how you can write a small code that prints something in the terminal. So just you see how this Python works. Okay, so if you want to print anything, the best thing in Python is that most of the keywords that has been used like are the normal words that we know, like there is input, print, like while loop, for loop, and functions, and all these things that they are the same words that we use in our daily life. So it is little bit easier for us to understand. You will see that some things that are new and that are special for machine language, but other words are like very very familiar to what we use in our daily life. Okay, so here, as I told you, we will do some printing if we want to print something. So we just need to use the function print. So this function print is already defined with Python. So once you install Python, you don't need to care about this function print. It is already there. So you click, you put print, and then inside it you put what you want to print. So if you are going to print a string, because string is one of the variables that we will discuss after, but string means that like a sentence, like a text. So if you want to print a text, you need either to add this or this. For other programming languages, this is different between this and this. So one is for string, another one for the characters. But in Python, this is the same thing. So we don't need to think about it, like semi bracket or one bracket. Don't worry about it. So okay, let's put this and here, and we can write our anything we want to print. So most of the time, they always use hello world. Okay, but you can print anything you want. Okay, so once you have already put what you want to print, you can click on either this, or you can click on shift enter. So when you click on shift enter, this will run the code. Let me see, running. Okay, let's install it. So once you, I think when you have the new virtual environment that haven't been used for Jupyter Notebook projects before, maybe you need to install the kernel IPY kernel. So you see that once you run the cell, the installation window will pop up, and you just need to click on install, and it will install the Jupyter Notebook extension. Not the extension, but the kernel for your environment. So when we are talking about the environment, it is independent than the VS Code, because in VS Code we installed a extension, but the kernel that we needed to install now, it was for the Conda environment. Okay, so don't worry about it. When you run the cell, it will pop up here. You just need to click on install, and everything will be there. And you do this only one time once you create a new virtual environment. You don't need to care about it after. So here you see that it is showing us hello world. The good thing in Jupyter Notebook, to print something, you don't need always to use the function print. So if you want to print hello world, you can just put hello world. Okay, something like this. So you see here, when we do hello world directly in the cell, even without the function print, it is printing it. But what happens, so you need to have this this function, like the word that you want to print, for example, or anything you want to print, it should be like the last line in the cell. So if you have anything before that, it won't be printed. Even if it is like a normal, like if it is the same thing as this one, it won't be printed, because how Jupyter Notebook works, like it takes the last line. If there is anything that needs to be printed, it will print it. But otherwise, if you have like 1,000 lines, it won't print 1,000 lines. It will print the last line, which is this one, for example. But most of the time, you need to use the function print, so that you are sure that there is no problem with your code. Okay, so this function print can be used to print a lot of things. So it can be this one here, as you can see, a string, which is text, a normal text. It can be like word, if you want to print a number, so you can print a number. If you want to print a mix between them, you can do the same thing. So for example, my age is, for example, and you want to give the age here, for example, so you put here, it is an integer, which is a number, but here this is a text. My age is, this is a string, and this is a integer. So if you print it here, it will show you like my age is 26, and you can do a lot of things. So if you want to add a lot of things in this print function, you can add it. So you don't need to think like you will have only one parameter, but you can have as much as parameters as you want. So I can add anything here, and I can add anything here, and when you run it, you will have all the things in the same line. Okay, If you want to jump the line, so you need to click like this bar and then N, and if you do that, so it will jump the line. So if you want to have a space between this and this, you can do this and T. Okay, and here you will have like a big space between this word and this word, and the same thing for all the other strings. So for this part, we have just I just gave you how to print things, and in the next videos we'll discuss about the variables and list and all the basic things that you will need to create a Python code. And after that, we can talk about how to use all these basic Python codes for your advanced medical imaging projects. So see you there. Bye bye. Now let's talk about data types and variables. So what are variables? Which mean when we talk about variables, and you will see that it is the most used term in any programming language, which means where you want to store your data. So when we are talking about data, there are a lot of types of data, but in programming language, a data can be a text, it can be a number, it can be anything like that. So you don't, if you want to use it most of the time in your project, so you need to save it or store it in somewhere. And this somewhere is a variable. I am just saying it like this so that it will be easier for you to understand, but you will see that when we do a lot of projects, you will understand what is a variable exactly. But for now, I am just saying it like this. Variable is a place or like someone that can store your data. So if you, for example, you have a number, which is like, for example, let's say in 2023, which is the actual year. So if you want to save this actual year in somewhere that can be used after, so you can save it in a variable. And if you have your name, for example, and you want to save it somewhere. So for example, Muhammad, and you want to save it somewhere, and you need to use it maybe after that in another project or another code or somewhere else, then you need to save it somewhere. And this somewhere also is a variable. So there are a lot of types of variables. The most known ones are the integers, okay, integers, and there are the string, there are the characters, but for Python we are not using them, which are char for the characters. We are not using them. We have only string. For C++, for example, there is the string and the char, which is character, but for Python you need only string. There is the float or double, which is for which is for float variables, like some like 3.3 or 3 point something. This is float number. And you have the bool, which is for boolean, which is true or false. Okay, so these are the most used types of variables that we will need for our projects. But of course, advanced variables, which when you have a return from a function, when you have an image, when you have an array, when you have a lot of things, all these things can be stored in a variable. But for now, since we are still starting with Python, we are just talking about integer, string, float, or boolean variable. Okay, so to talk about these, what you need is to define the name of the variable. So for example, if for me, you can give any name you want, but preferably you need always to give a name that has a sign about what is going to be stored in this variable. So if you want to store an image, you cannot, like, I'm not, when I say you cannot, I am not saying that you can't, like, in terms of Python language, but preferably if you have an image and you want to store it in a variable, we don't have to store it in a variable, for example, called, I don't know, video. You can't store an image in a variable called video. Like maybe in future code, when you are using this variable, for example, you will forget that you saved an image in a variable called video. This is how it works. So you need to save the data that you have in a place when you will recognize when you read. So for example, if you are saving an image, like, so let's say, for example, image for the lung. So preferably you can put it like image of lung, for example. Okay. And you need to notice that variables, when you have a name of variable, you don't have a space between the words, and the variable shouldn't start by a number. So you cannot put like one then name of the image. You cannot use the dash or equal or plus or all these things. You cannot use them for the name of a variable. So this is, it should be like easy and yeah, easy and you can understand after in your code. And of course you can use like uppercase or lowercase. There is no problem for this also. So this is how we can call a variable, but this is the first part, which is the name of the variable. But after, we need to give the value of the variable, which is the data that you want to store in for in this variable. So here, for example, let's say int var, which is an integer variable. So when I want to store it, so let's say equal. So there is two parts which are split by this equal. The first part, so let me just give here, you have the name equal value. This is how we can define it. The first part, which is the name of your variable, and the second part, which is the value that you want to store in the variable. So for us, the name is int var, which is the variable, and the value that we will give, for example, integer, which is 12, for example. Okay, so we have 12, which is a number and integer, and it is also a variable now. So if I want to print it, I can print, let's say here, I can print 12 like this. But if I don't remember the value, so if I have a value now and I will store it somewhere, and in like, I don't know, I cannot always recognize or always remember the value of, if it can be integer, it can be anything, I will not always remember this value. So once I store it in a variable, I can only call the variable, which is here int, and int var, like this. So once I call this variable, the variable will give me the value that I stored on it before. So if you have like, let's say 1,000 line of code, so in the first line of code you store this variable, and in the line 1,000, in that case you can just call this variable and it will bring the value, which is 12. So if I will just run it, shift enter, I am always using shift enter to run the cell. So when I will run shift enter, I will see here 12. So I don't need to remember the value that I stored. I just put it somewhere, and after that I just return it from this int var. Okay, so this is how it works when creating a integer variable, and the same thing can happen for the other types of variables. So for example, I have a float var. I don't know why I'm writing float var, for example. So this can be 2.3, for example. And if you will want to print it, the same thing, it will be float var, and it is here 2.3. So if you want to check if this variable is exactly a integer, and this variable, for example, is exactly a float, what you can do, there is a function in Python called type. So this function type, if you give it anything or any data in the parentheses, it will return the type of this data. Okay, so let's give it the int var, for example, and see what it will give us. So it is class int, which is the integer. Okay, int is for the integer. And if we give it the variable float var, and here you see that it is float. Okay, and if we want to do the same thing for a string, so let's say string var, and then here we give it, this is a string, something like this. Okay, and now if I print the value or the type of the string var, it will be a str, which is string. Okay, and the same thing for booleans. So if I do bool, and then for example equal to true. Okay, true. Okay, now let's just put it bool. I think we need to add var, so it will be the same. So we have here bool var. Okay, so now you see that it is bool for booleans, and these are the basic types of variables that you can face. Maybe for the integer and for the float, you will understand that, yeah, we can use these as numbers, and for the string we can use it as a text, something like this. But maybe you have a questions about the boolean, what does it mean or why we need it. So most of the time we use the boolean variables for the conditions. So if you have a condition where you want to stop your code, so if you are doing some kind of process and you want to stop it somewhere, you need to have a condition or a flag where we enable this flag means that you need to stop your process. So this flag can be a Boolean variable. So when your process is completed, you can activate this flag into true, which means that the process has been completed. And once the process is still running, which means it is not completed, you can put this variable into false, which means that it is still running. This is only one example, but you will see in the future codes in this course, you will see that you can use it in a lot of places that you cannot imagine. So these are the basic types of variables that you may face while using your project. But of course, we will use, or we will cover a lot of things and advanced things that you can use for your projects. But just stay with me and we can see them later. So now, after that we spoke about variables, let's talk about the lists, which are one of the most important things that you will need and or you will use always for your like programming projects using Python. Okay, I'm not saying that most of the time, but like in a lot of important projects, you will find that you will need these lists, and you can find them anywhere in any project. Okay, so we will see how to declare these lists, how to manipulate them, and we will have few examples. But of course, we cannot cover all the terms available for the lists. But if you want to know more, you can always check the documentation for that. Okay. So before that, let me just create a text here so that we split between the variables and the list. So here, when you add, you want to add a new cell in Jupyter Notebook, there are two types of cell. There is a code where you write a code, and there is the markdown where you just write a text. Okay. So when we have one hashtag, meaning that this is a heading 1. If we do two hashtags, meaning the heading 2, like the same thing, H3, H4, etc., etc. Okay. And if you don't write anything, this means that this is a paragraph, a normal paragraph. Okay. So this is just if you want to structure your code while using Jupyter Notebook, you can do that. So let me put a heading 3, and this is this part is for the list. Okay. So now what we will do, we will create a new list. So to create a new list, it is the same thing as creating a variable. You have the name equal the value. Okay. So we have the name of the list, and then we have the value of the list. So the thing here, when you create a list, you can either, there are two ways of giving the value. That is the first way, which is like giving an empty list, where there is like you create the list, but it is empty. There is no value inside it. And there is the second way, which is creating a list with its value. And of course, you can always update the list. You can add values, or yeah, you can add things, delete things from the list. All these things are available when you work with the list. Okay, so let me just give it a name. So for example, my list. Okay, so to create a list, you need to use the brackets here. So when you have the brackets, meaning that you are working with lists. Okay, so now if you just leave it like this, it is an empty list. So if I will run this cell, if I want to print the list, okay, print my list, you see that it is empty. So there is nothing inside this list. But if you want to put anything inside this list, if you want to do it while declaring the list, so you can directly here fill your values or your objects in the list here. So if you want to, you have a list of integers. So we have 1, then 2, then 3, for example, like a list which has 1, 2, 3. So it has 3 values, and these are the values that are in this list. Okay, so if I run it now, you will see that this list has 3 values instead of only 1 value. Okay, so this is how to declare a list. And but if, for example, let's say you want to add another value to the list, but not while declaring it, but maybe you are doing some work in your projects, and in some point you want to add a new value or new object or something like this in your list. So to do so, you can just use the function like my list, and when you want to add use a function from the functions declared in the object list, you just need to click on point, like the name of your list dot, and here you will see that you will get all the functions available for the object list. Okay, so there is a function called append. So this function append will allow you to add a new value or new object to your list, and it will be listed at the end of the list. So if you add anything, it will be here at the end of the list. It will add something. So let's say I want to append a value 4. Okay, so I just run it. If I print, and there is something else that you need to know. So for example, we run this cell after the print, but now the value of the list, which is my list, is updated. So if I run this, it should give you the this list plus the updated one, which is plus this value. Okay, because this list has been this value has been updated after running this cell. Okay, so this cell doesn't mean that since it is before this means that it is not updated, but all the workflow is updated after running each cell. Okay, so here if I just print the list, you will see that 1 2 3 4 we added the value 4. So here we are taking a very easy and simple example, which is like only integers. But in your project, you may have like an object. You may have images inside the list. You may have a lot of things in your list. But this is only one easy example for that. But the other thing here, this is a list of integers. So let's say if you want to declare a list of strings. So let me just create a new variable, my list. So let me just put string, for example. So it is the same way, like you have the brackets, and then inside the bracket you can put the list of strings. So for example, let's say hello, and then for example, how are you? Okay, so now we have a list with 4 values, which is hello, how are you. For example, this is only one example. You can put anything, like you can put texts, like the whole text can be only one value for the list. So you have one text, another text, etc, etc. So just to have a simple example, I am taking only words. Okay, so if I run it here, you will see that now we have a string, a list of strings. Okay, and we can do the same thing for doubles. We can do the same thing for any type of object that can be used in Python code. But the other thing that can be which is the advantage of using Python, because sometimes when you use other programming language, for example C++, you will struggle a little bit when you want to create a list, especially when you want to add values. It is not easy to, as you can see here in Python, it is very easy, but for example in C++ it is very hard to do some kind of easy stuff, but they are difficult in other programming languages. But the other thing also, here in Python you can even have a list which has a mix of values, like a mix of data types. So what does it mean? So you can see here we are creating a list with only strings. This one is only with integers. You can create with only booleans or only floats. But you can also create a list which has a mix. So you can have a list that can that contains string, int, like floats, booleans, everything there inside one list, which is not possible in some of the other programming languages, such as C++, for example. You cannot have a mix of data type in one list. You should always have one type of data type, sorry. So for example, if I want to create a mixed list, so for example my list mixed or something like this, now we can, for example, create the list with mix types, the data types. So for example, here I have my age is, for example, and now here 26. Okay, so this first object from the list, which is a string, sorry, and the second one is integer. Okay, and you can add other things, for example true, like this is true. Okay, something like this. So you just run it, there is no problem here. Let's if you want to, yeah, okay, if you want to print it, my list string, not string, mixed. Okay, so when we run it, we have the my age is 26 and then true. Okay, you can see that you can have a mix between the values. And if you want to do like there are a lot of types of functions available in the list that you can use. So I will just give you a few of them. So what you can do, for example, if you want to clear your list, so you have all these values, if you want to clear it, like you will have a new, like with the same variable, which is my list, sorry, with the same name, which is my list mixed, for example, but I want to delete all the values which are here. You will see in some point when you do your project, you will always need some kind of clearing your list. So if you have some kind of data there and you process them, and maybe you will relaunch your process, or you have a loop that will be restarted. And once you are doing this, most of the time you will need to clear your list. This is only one example, but I will just show you how you can do that, and you can see if you may need it in the future or not. Okay, so let me just create here a new cell. So to do that, there is a function called clear. So you just need to call the function by putting the name of the list and then dots and then clear. Okay, so if I run this now, if I print the list, you will see that it is a empty list. There is nothing inside this list. Okay, so this is how to clear a list. And there are a lot of other things that you can do. There is, for example, the function sorted. Okay, so this function, there are two types of using this function sorted. There is the sorted normal function, which doesn't need to be used only for lists, but there is a function called sort, which is only for list, and it can be called only when using the list variable. Okay, so here, let's say, for example, we have a int list equal to, let's say, 5 0 2 12 1 5 or something like this. Let's say 8. Okay, and now if I have this list, you can see that it is not sorted. So if I want to sort this list, what I can do, I can just put int list, okay, then that sort. Okay, if I call this function, it will sort the list. Now if I print this list, int list, you can see that it is 0 1 2 5 8 12. Okay, so everything is sorted. So this is how you sort a list depending to which type of data you have. So if you have a string, it will sort it by the order of the alphabets. So A, then B, C, D, etc., etc. So depending to where you are using it, but most of the time we use it for integers or for floats. Okay, so this is how to sort a list when you are using it. And there are also other things. So for example, if you have this whole list, okay, and you want to select only one value from the list, so how you can do that? If you want, for example, to select the value 0, so you need to call the int list, and then you need to give the index of this value. And what you need to know while always using the list, let me just put it here. Okay, so always the first value of the list, it has the index 0, not the index 1, but it is the index 0, then 1 2 3 4 5. For example, for now we have only 5. In reality we have 6 values, but the indexes start from 0 into 5. Okay, so if we count them, it is 6 values. And also, if you want to know how many files or how many values you have in your list, you can just do this function, which is len. It will calculate the length of the list, and if it is a string, it will calculate the length of the string, how many alphabets you have in this, or how many letters you have in this word, or in this sentence, or in this text, all these things. Okay, so if I do this, you will see that we have 6 values in this list. Okay, So 6 values starting from value 0 into value 5. Okay, so now if I want to call this value, so I need to give the index 1. Okay, here I have the index 1. So if I do that, you see that for the index 0, index 1, sorry, why, yeah, I'm sorry, I'm saying this because now we have sorted the list, so the new value is 1 here. When because I am seeing at this value which is 0 from this old list and trying to print it. So if I want to really print this, so I need to delete this sorted. So now we don't have any sorted list. So if I do, or if I print the value with the index 1, you will see that it is 0. Okay, because here 0, sorry, yeah, 0 1. So here we have 1 for the value 0. So if we want to do the same thing for the value 12, for example, and then we need to give the index 3. Okay, so if we give the index 3, we get the value 12. And now let's say if, for example, you want to have like a range, so you want to have 0, 2, and 12. You want to have these 3 values. Okay, so what you can do, you can give a range starting from this point and ending to this point. So for example, if I want to print these, so I can start from 0 from 1, because the value 0 is starting from the index 1, and then when we stop, we can stop by n plus 1. So we want to have until 12. 12 is the index 3, but we need to put here until 4. Okay, so if you do until 4, so it will take from 0 to like 0, 2, and 12. So what does it mean? You start from the index 1, and then you take index 2, and then you take index 3, and index 4 is not included. So you take it, but it is not included. So you stop in the index 4. Okay, this means that you are taking these 3 values. If you want to take more, of course, you can just move this into, for example, if I put it into 5, then you will take also the value 1. Okay, so this is how you can take like a index or like a range of values from your list. So for example, if we want, say you want to have a range from the beginning, which you don't want to specify, so let's say from the beginning into another point, so you can just say everything until, for example, until 2. Okay, so if you do everything until 2, this means that everything here from the starting point until the index 2. So index 2 is not included, so you will take these 2 values, like the value with the index 0 and the value with the index 1, which is 5 and 0, like this. Okay, so there are a lot of things that we can do with these, but I just wanted to give you a small example because you will see that we will use them all the time when using the path. If we want to change any part of the files, like let's say Python, like daikon files, nifty files, we will always need to work with these kind of ranges. So if you want to delete the extension, so for example, if you have a path to file, path to file .dcm, for example. So let's say you will extract this file name, and you want to have only the file name without these extension. So once you have the whole file name, what you can do, you can just put, like, for example, let me just create a new here. So you have the file name, which is file.dcm, and now I want just to take the file, which is the name of the file without the extension. So what you can do, for example, this will give it a variable called file name. Okay, so file name equal to file, and it should be a string, because a path is always a string. I know that we didn't talk about this yet, but I am just trying to give you an example so that you understand why we may need these type of selecting ranges. But you will see in the future videos, you will see that this really helpful for a lot of things, when creating new files, when converting files, when doing a lot of things with the files for medical imaging, and of course, for even for other tasks, not only for medical imaging. But since the purpose of the course is medical imaging, so we will try to focus only on that. Okay, so now after having this file name, if I want to select the file name without the extension, so what you can do, you can just put here file, like let's say file name equal file name, and then here you will take everything, but you will not take the extension. So there are two ways of doing it. So you take everything until like 0, 1, 2, 3, and 4, because 4 is not included. So you can do that, like from everything into 4, or you can do the reverse that. So everything minus, and then you take these, which is it is also 4. So you take everything into 4 or everything minus 4, it is the same thing. It will give you the file name here. Okay, so this is just one example. That don't think about it. I am just saying this so that you will see the relationship between what we are doing now and what we will do in the future. But just to give you an example, let me just delete this. Okay, so this is how to work with lists, and as I told you, there are a lot of things to do that, but I am just showing you small examples. And if you want, for example, I can even show you something like if you want to, for example, you have a list which has these values and you don't know the index of which value you have. So for example, you want to have the index of the value 2. So to do that, there is a function called index. So we have int list dot index, and inside this function index, you give the value that you want to search. For example, the value 2. So if you give the value 2, it will return the index where is the value 2, which is 0, 1, 2. So the value 2 is in the index 2, which is correct. So if I want to do for the value 12, for example, so it is in the index 3. So this is also helpful if you are having because now we are only working with integers, but you will see in some point you will have a list that has objects and kind of data that you are not very familiar with. It can be image, it can be file, it can be anything. So when you have this and you don't know what is the index of this value, just give the this type of data or this object in this function index, and it will return the index where it is this value. Okay, so this was for the lists, and if you have any questions about this, you can always leave them in the community, and I can answer you as soon as I can. And yeah, let's go to the next videos. Now let's talk about the conditional statements. So what is conditional statements? Which is when we use an if. So we all know what does it mean if. So if something, let's do that, else let's do something else, something like this. So here where we use if, so if I don't know, if the PC or the computer is turned on, then let's play games, else let's turn it on, or else let's go outside, or something like this. So this is what is the if statement in our real life, but we can use it also in programming project, and you will see that it is very, very useful, and you will use it all the time. Okay, so let's have a small examples, and you will see that it is not a big deal, and you can use it whenever you want in your project, and it will be very, very helpful. Okay, so before that, let's create a markdown. Here let's put like conditional statement. Okay, let's run the cell. Okay, now the if, because in any programming language there are always some keywords that are already reserved by the programming language runner. So for Python, here we have the if. Here if is one of the keywords that are already reserved by Python, so you cannot use a variable called if or something like this. And also here when we use if, meaning that we are using the conditional statement. So I will give you the syntax, and then we get an example. So if something, let's say if the PC is turned on, then when we say then means that we have the columns. Like when we have columns, this means that we have then, and here we do the thing which is, for example, play games. Okay. And yeah, this is how you can define the statement. If the condition, then is the columns, and then here you play games. Else, if because there are two things, there is the else if and there is the else, only else. So when we want to have another condition that is already defined, which is, for example, if the PC is not turned on, but if the, like, let's say PS5 is turned on, so for this reason we can say else if, which is elif. We can rewrite it elif, but it means that else if the PC is not turned on, but the PC is but the PS5, for example, is turned on, then, which is the columns, and then let's play games also. Okay. Else, but because we can make as much we want for the else if we have like a lot of conditions, we can always say if else if else if else if else if. But when we have like the final like, if we are giving all the conditions and we want to say if none of these conditions is true, then let's do something else. So for here, let's say else means that if none of the other conditions are true, so like, which means if the PC is not turned on and if the PS5 is not turned on, then let's go outside, for example, go outside. Okay. So this is just a syntax, how it works. So if the PC is turned on, let's play games. If the else if the PS5 is turned on, also let's play games or do something else if you want. Else, let's go outside. So here is how we can write the statement. But now let's take an example. So let's take the easiest example that can be used for the else if, like for the conditional statements, which is, for example, we have x, it is a variable, integer variable equal 5. So I want to see if the value of x is positive or negative. For us as a human, we already know that it is positive, but if we want to have a general code that will always check if the value of x is positive or negative, like either this value will be defined directly or will be entered by a user or something else, but just let's see if this value is positive or negative. So we can say that a value is positive when it is bigger than 0 or equal 0. Okay, so to do that, let's just do if x is bigger, because if we want to say only bigger, we can say bigger, or if we want to say bigger or equal, then we can say bigger and we add the equal, means that bigger or equal, then the value which is 0, which means if x is bigger or equal 0, this means that the value is positive. So here we can say print the value is positive. Okay, positive. Okay, and else if the value of x is less than 0, which we don't even need to have the else if, but we just need to put else, which means if it is not bigger than 0, then all the other statement that we can have, which is less than 0, this is the only thing that we have. But we can say that if it is less than 0, or we can just say else, then here, because else is like everything excluded from the other condition. So the first condition that we have, which is x bigger or equal to 0, then else is everything which is not included in that condition, which is all the values which are less than 0. So print value is negative. So here, if we run it, we can see that it is positive. If I just put here -5, it is negative. You see? So this is like the easiest way of representing the value of how to represent the if conditions. But you will see in when we use like big project, and when we use like a lot of for loops or something like this, and sometimes you want to stop the loop or stop the project, or check if your path is ready or not, check if the data is already in the folder or not. So all these checks we can do them using if and else. Okay, so yeah, this is for this video, and you have any specific question about this, you can always leave it in the community or in the comment section of this video. So see you in next video. So now let's talk about the for and while loops. So for and while loops are one of the most important things also for any programming language. So whenever you have a process that you want it to be repeated several times, then you will need to have a for loop or while loop. In general, you will need a loop so that it will loop the whole process. Like if you want to choose the end of the process, so you can do that, or if you can just leave it an infinite loop, it will be an infinite loop and it will be running all the time until you do something specific to stop it, but there is no condition to stop it when it is running. So now we are not going to talk about the infinite loops because they are like, we don't use them actually in our daily projects, but you will see that if you want to do it, it is very easy to do that. But now we will just talk about the for loops and while loops that has the starting and ending points. Okay, so the syntax of a for loop, which is for, and then we give the index, for example I, and in, and then we give the like, we can say the bucket or anything you want to call it, a group or something. So for one item from the group, so for I in a group, so this group can be a list, can be a range, can be a string, can be anything you want. We'll do some tests and you can see that it can be anything from a group of objects. Okay, so for example, if we have if we want to create a range that has integer values, so there is the function which is already implemented in Python called range. So this range will create a range of integer values. So this range function takes like minimum it can take only one parameter, and maximum it can like, I'm not saying maximum, but most of the time the most number of parameters that can be given to a function here for the range function are 3. So there is the starting point, the ending point, and the step. Okay, step, let's say something like this. I'm just writing them like this, but this is how it works. We need the starting point, ending point, and the step. But if you prefer giving only one value, for example 3, so we can do that, but what will happen? By default, the starting point will be 0. So 3 is the ending point, and by default the step is 1. Okay, so the step is 1, the starting point by default is 0, and the ending point that we have given is 3. So this is how it works. But if you want to customize the starting point and the step also, then you can give them. Okay, so for us, since we are giving only one value, this means that this is the end point. Okay, so if you want to see what are these values, you can just print them. So if we print I here, now you see that we have we have 0, 1, and 2. So the range starts from 0 and ends into 3, and 3 is excluded. The same thing as we had in the indexes of a list. So this is the same thing here. Okay, so if for example I want to do a for loop in my list instead of in a range like this, so how we can do that? Let me just create a list, for example. We can call it like loop list. Okay, and we can give it some values. So we have 3, 0, 5, 1, 8. Okay, now what we can do if we want to have the values from this list, there are 2 ways. So most of the time in C++ or any other programming languages, so what they do instead, so you remember when we talked about the list here, yeah, when we talked about the list, and we said that if I want to have a specific value of the list, and I can give just the index here, the index of that value. So for example, the index 0 means that the first item from the list, and index 1 is the second, third, fourth, and fifth. Okay, and so on if we have more more values in the list. So here we can use that feature. So what we can do, if I want to print the values of this array or of this list, what we can do, we can print by, let me show here, we can print by loop list, and we give it the index I. Okay, so when the index I is 0, we will print the value in the range 0. When the index is 1, we can print the value with the index 1, which is this one, and then 2, 3, etc. But the thing here, you see that we are specifying the range into 3, but the list here has 5 values. So there are two ways to do that. We can either directly here give the value 5, but this is not a general answer, because if you change the list, if for example I just add a file or sorry, I add another number here, for example, let's say 9, so I need always to update the value here in range, and this is not a good way to do your code. So what you can do, you can put it in general. So in general, what does it mean? Because this value here, since now we have 6 values, so it should be 6. So 6, what does it mean? It is the length of the files. And what did we say? I don't know if it is still written here. Maybe I delete it. But yeah, what we said, if we want to return the length of a list, so we have the function called len. So if we call the function len and we give it the for loop, the list, which is loop list, it will return the number of items in this list. So we can use this feature. What we can do here, we can give it in the range. Okay, so instead of giving 6, we give a length of the list. So when we have this length of the list, it will return the number 6, which is already here the number of items in this list, and it will be used in the range function, and we can directly test it if you want. Here is the output. Okay, but the idea here in this function, if you want to add anything now, if I want to add, for example, 10, I won't need to update anything in the range. It will be updated directly by the function length, because it will return the new length of the list. Okay, so if I run it, there is 3, 0, 5, 1, 9, 8, and 10, which are all these values which are in the list. Okay, so this is another way, but there is an easiest way to do that. Most of the time, people use this. Maybe there is a specific purpose for that, but the best way to do this is to not use any thing from the range. For example, if I want to just take values from this list, what I can do from I, let's always keep it I, from I, for example, and instead of giving range, we give the whole list. So if I give the whole list, what does it mean? For I in list. So since the list has items, then I will be the items. So now we have the items as integer values, but it can be images, it can be arrays, it can be objects, it can be anything here in this list. So always when we say I or anything, you can put here for variable, for I don't know, for pycad or something in the list, which is this one, for item in the list, do something. But now we don't need to print this, we just need to print the I. Okay, so if we print the I, it will take the object from the list. So it will take 3, 2, 5, 1, 9, 8, and 10. So you see that this is easiest way to do it, instead of taking the whole list, which is like you calculate the length and you give it to the range, and you need to give the index in when you call the function here, when you call the list, and all these things. But you can directly take it like this for I in the list, and you do anything you want. Here we are printing, but you can do anything you want with this. Okay, so this is how we use a for loop. This is like an easiest example for that, and advanced examples we will see them during the course when we start working on project for medical imaging. Okay, so now if we want to work on the other the other type of loops, which is the while loop. So the while loop, it has the syntax while. Okay, and we already know what does it mean, the word while. So while the PC is turned on, you can I don't know, watch movies, something like this. And yeah, so the same thing will be applied here, while, and we give the condition that we want, and then inside this while loop we can do anything we want. So for example, let me say while before that we need to for example, if I want to have a condition, we should have like the precondition, which is, for example, we have I equal to 3, for example. Let's say while I here is less, for example, than 9 or something like this. Or yeah, we can say this, or let's make it easier for a, and we can what we can do for a is let me just see, for a is less than I. Okay, for a is less than I, then we can directly do something else. So what we can do, the best way to do that is just to increment this this a. But before that, since we want to increment it, we should have the initial value of this. So what we can do, let's just define a equal to 0. So for now, a is equal to 0, and it is always less than I. Or even if you don't want to define this I, we can directly put here for a, while a is less than 8 or less than 3 or something like this. What we can do, let's print it. So print a, okay? But if we just leave it like this, like it will be like, this is one of the infinite loops that can happen. Because if we just leave it like this, a will be always less than 3. So this is one of the infinite loops that we can have, because it is always true. Always a is less than 3. And since the loop is always true, means that it will be always, like it will be infinite loops. It will always be running because there is nothing to stop it. But if we want to have a stop it in some point, what we can do, we can add value to this a, so that in some iterations this condition will be false. Okay, so what we can do, we just need to increment this a. So a, we can add like a number 1, so we can have a plus 1 to the actual value of a, so that the value will not be always 0, so it will be 0, 1, 2, and once it comes to 3, it will stop. Okay, so what we can do, we can do it in two ways. We can just put a equal to a plus 1. What does it mean? We have always the new, this is the new a, equal to the past a, which is this one. For now it is 0, but after some iterations it will be updated. So what does it mean? The new a plus the previous a plus 1. So the previous a plus 1 will be the new value of a, and then the loop, it will come back here and it will see if the new a, which is this one, is less than 3 or equal to 3. But at the first point it will be 1, so it is always less than 3. So the while loop is always true. So it will come here, prints the a, and it will come, then we have the new a equal to 1 plus 1, because the old a was 1. So we have 1 plus 1, then it will be equal to 2. So 2 we will take it here while we see which if the condition is true or false. So we have always 2 is less than 3. So we can print it, and then we add 1. And here in that third iteration, what happened? We will have 3 less than 3. It is not true because 3 is equal to 3. So the condition is false. So once the condition is false, then the loop will be stopped. Okay. So we can try it here. We can just run it. So we have 0, which is the starting point. It printed it, added 1, then it come to here, it is 1 is less than 3, then it printed it and added 1, then it comes here, then it became 2, so 2 is less than 3, it printed it and added 1, then we have 3, it is not less than 3, then the loop has been stopped. Okay, so this is how it works for the while loop, and you see that it is almost the same as the for loop, but there are some cases where the while loop works better than the for loop. But yeah, this is a small example of how to use the for and while loop. But as always, more advanced examples will be covered in the next videos. See you there then. Now let's talk about functions. So the functions are, they have the same name as the concept in mathematical functions. So for example, when you have fx equal to, let's say, 3x plus 4, okay? So let's say you have a mathematical function like this, and whenever you replace the x by another by a number, it will calculate the f the x, which is y. So fx is y, and the value of this, when we replace the x by the given value here in the parentheses, it will give us the y. Okay, so this is a mathematical representation of a function, but you can imagine that it is the same thing that can be used for programming. But instead of only mathematical operations, it can be a lot of things that can happen after replacing one variable, two variables, three variables. So it can be something like x, e, I don't know, a, something like this. And you will have an equation with, let's say, plus 3e minus 6a, okay, something like this. So it can happen like this. So you have a function that has the x, the e, and a, and whenever you replace these values, you will get a new return, which is the like, let's say for example, x equal 1, then it is 3 plus, and e equal 1 plus 3, which is 6, and here a equal to 1 also, so you have minus 6, so you have 6 minus 6 equal to 0. Okay, so this is an example. This is the return, and this is the equation, the core of the function, and these are the variables of, or the parentheses. So you will see that the functions in programming, this, we can define it at the same way that we are defining a mathematical function. So let's just delete this. So as you saw, for the for loop, we had the keyword for the while we had the keyword while, for the if we had the keyword if, and so on. For the functions, we have the keyword def. So whenever we write def, this means that we are defining a function. So we write def and then the name of the function. So let's say function, for example, name, okay? And then you will have the parentheses, the same thing as a mathematical function, and then you have 2 points. 2 points, or the columns. Columns means that you are going to write the core of the function. So now, whenever I write here, is the core of this function. Now we have def, the keyword, the function name, here the parentheses, where we can write the parameters of the function, or these, when we had the x, y, z, or something like this, the x, e, and a that we had in the example, we can put them here, and then we can use them in the core of the function here. Okay, so let me just delete this. Now, as you can see, this is the simplest syntax of a function. To have an example, let's just try to do a mathematical equation, the same thing as we had before. So let's say you have x here that will be given in the parentheses. Now we want to do a mathematical operation with this. So let's say y equal to 3 by, and when we want to multiply a number by a number or something in programming, we don't use the x, but we use the star. Star means that we are multiplying two values. Okay, so let's say 3 by x plus let's say 4. Okay, and then when we are calculating this, we don't have any return of the function. So if this function work without any problem, but we are not getting the result. So there are two ways of doing it. You can either print y directly here, or you can return it. So let's return the value of y, and then this y that will be returned from the function, we can use it for anything we want. So let's run this cell. Now you have this function defined. If I want to use it, so whenever you want to call the function, you can just call it by its name, so function name, and then here you give a value for x, so let's say for example 3, and then let's run it. So you see here we didn't add the print because we are working on Jupyter Notebook, but preferably you need to add a print. Okay, something like this. So print, so I'm using it. So if you are not using Jupyter Notebook, then if you don't add the print, you cannot see the value. So now you can see that it is 13. Okay, so we have 3 by 3, 9 plus 4 equal 13. Okay, so this is a simple way of defining it. If you want something like you want to print a word or print a sentence, adding the word from the parameter, let's add another function. So for example, we have print, let's say sentence. Okay, and then let's give a word. Okay, now we are giving a word, and then after that we use it in the our function. Okay, so now let's say for example print okay, say my name is like this. My name is the word that we will give here. Okay, now if I will run it, and if I want to use this function, the same thing. Just for now we don't need to add the print because the function is already printing, so we will just call it. So print sentence. Okay, and let's give the word, for example, Muhammad. Okay, now let's run it. So my name is Muhammad. You see that it is working even if we don't have any mathematical thing inside this function, but this is how it happens whenever you give a parameter, or you can give multiple parameters if you want in the parentheses. You can use them inside the function and return a value or return a result that has been calculated with the values that you gave in the parameters. Okay, and other thing that you need to know, so whenever you define a function like this, for example, this means that this value is required. So you cannot just call this function without giving a word. So let me just show you. If I just call the function without giving a parameter, it will give us an error saying that one missing required potential argument, which means this argument is required. We cannot call the function without it. But if you want to make it like optional, so for example, if you don't always want to give parameters in your function, you can add a default value that can be used if or in case you don't give the value when you call the function. So how you can do that, you can just come here and add a default value. So whenever you give a value in the parameters when defining the function, this means that this is a default value that can be called if you don't give a value to the parameter word when you call the function. So for example, let's say pycad. Okay, so I will run it. Now if I run this, you will see that we don't have any error and it is printing the word pycad. But if I give the parameter, let's say Muhammad, and I run it, now we are having the word Muhammad here. So this is what happens if you have multiple parameters in your function, because this one is very easy function. You can see that there is nothing. We are just taking the word and printing it. But sometimes you can have a complex function that does operations, and maybe you will have a lot of parameters here in your function, and some of them are always required and others are optional. So whenever you have an optional variable, preferably you should give it a value, or if you don't even want to give a value, you can just give it the index none. So you just give it none. None means that this value or this variable doesn't have any type and doesn't have any value. So it is not like you are giving it a string, which means that this variable is a string, or you're giving it an integer, which means this variable is integer. When you give none, means that this is an empty variable that doesn't have any type or any value. It is none, something like this. So yeah, this was about the functions. If you have any questions about these, please let me know. Now let's talk about classes. So we saw before the variables, which are just something to represent a value, an image, an object, or something like that. We saw the functions, or where you can do any operation between some variables and return a value or multiple values at the end of the operation of that function. Now let's see classes, which is more advanced things inside it. So the object-oriented programming. Now we are starting it with the functions. So we spoke a little bit before about objects. We didn't spoke about other, but we used the word object, but we didn't know what is object. Now let's define an object. So object is something like if you cannot represent it in one thing. So for example, if we have a company, let's say, and the company has employees, so the employee cannot represent it on only one thing. So if, for example, for your company, whenever you represent an employee, you give it name, ID, and let's say age. Okay, so whenever you have an employee, you represent it by his name, his age, and you give it a unique ID for him. So when you have this, you cannot represent all these things as one variable or one function. You can do it by function, but it's not a good way of doing it. You should represent it as an object called employee. So whenever you want to represent an employee, for example, you want to call one of your employees, or you want to define a new employee, you should give it all these. Let's say instead of the age, let's give the name, email, address, and the ID. These are three information that you will need for each employee. Okay, so let's say here to define it before that. So let's say before writing it, let me just create a markdown. So we have an employee here, is represented by his name, his email address, and his ID. Okay, so these are the information that we'll give to an employee. So let's define a class called employee, which will represent all these things at the same place. Okay, so whenever we call the object class, the object employee, it will have all this information. So to do so, let's just define the class, and as we said, we have always keywords for each thing. So for the class, we have the keyword class. Okay, so class, and then you need to give the name of the class that you want to give, which is for us employee. Okay, then you need to add the colons. You don't need to add parentheses. By default, in some points you will need to have parentheses, but this is not something that we use daily. But for now, we just keep it simple as you see here. Okay, so now you have this. We have this class. Now we can write the core of the class here. So there are a lot of ways of writing the core of the class depending to what you need. But for us, we said that whenever we want to create a new employee, we need to give it a new employee, or we want to call a previous employee or an existing employee, we need to have his name, his email address, and his ID. Okay, so let's give it the most used way to do that, and the most easiest way to do it, and most of the time use the way that I will represent now, because you can do it with another functions or something like this, but it is not good way of doing it. But the most, or the convention one, which is creating a constructor. We call it a constructor because whenever we construct new object, for now, whenever we construct new employee in our database, we should have the three variables: name, email address, and ID. So to create a constructor, it is a function, but special for the class, which will be called automatically. You don't need to call it. So it will be called whenever you create a new object. We will see that in a few minutes, but let's just do it for now. Let's say you want to define the constructor. So the constructor, as we said, it is a function. So we should have the keyword def. And then this, the functions that are inside the class, and they will be used inside the class, should have the name inside the two underscore. So before the name and after the name, you should give underscore. So the function or the constructor of a class should have the name in it. Okay, so to initialize the class or initialize the objects, and then of course we should have two underscores here. So two underscores before and two underscores after, and then you have the parentheses, as we said, and after that, you should have the columns and the core of the function. Okay, but now since we are working on classes, you should have a another parameter that will be always in your functions that will be used inside the class. So whenever will be called inside the class or called outside the class, but since they are defined inside the class, preferably you should add the word here self. What does it mean self? If we don't use self and we have like 3 or 4 functions, or we have 2 functions plus a variable inside this class, and we want to call one of these functions inside the function that doesn't have the word or the parameter self, we cannot do that because the function is not defined if it doesn't have the word self. So whenever we give self to a function or to a variable, this means that this function is one of the functions of the class. So you can use it inside the class, outside the class, and it will be recognized always. But if you don't do that, this means that you define the function that you are writing it inside the class, but the class doesn't consider it as one of its functions or its variables if you are writing a variable. Okay, this is the simplest way to say it, but let me just show you how we can do that. Now we have defined the function in it. We gave the parameter self. Now we should have the variables name, which is the employee name, email address, and ID. So to do that, we said that we will initialize them whenever we create a new employee. So, and we said that the constructor will be called automatically whenever we create a new object, which is employee. This means that these parameters should be given to this constructor, and then it will be used to initialize the employee. So to do that, let's just give them in parameters. So we have the name, we have the email, and we have the ID. So these are the parameters that are required for this this constructor or for this object, which is employee. Now let's just give them to the name, because now we are just giving the values here, but we need to put them somewhere in the database. So we have self.name. So the name of this employee is name, because whenever we initialize a new employee, meaning we have the name, but since we don't give it the value here, means that the name is empty. It doesn't have any value for the name, no value for email, and no value for ID. So we say that self.name equal to name, which is the value that we gave here. So we can even give another thing here. Let's say self.name employee or something. It can work, no problem. But when we need the employee name inside the function, we cannot call it by name. We need to call it by name employee. It can be something like this. But by convention, we prefer using the same word, which is name, but this is only by convention. As I said, if you want to change it, you can change it. Okay. Now, if I want to do the same thing for the email, so self.email equal email and self.id equal to ID. Okay. Now, this is how we can do that. You just initialize these. If you want to test them, before doing that, let's just run this. And before doing before adding anything inside the function, inside the class, let's define one employee. So let's say employee 1, okay? And then let's just use the object employee. Now, if I just run this, you will see that it will give us error because it will need, so you want to initialize an employee, but you are not giving the name, the email, and the ID. So since you are not giving these, then you need to like the function will you cannot create an employee without this information. So you need to give them here inside the parentheses. So for the parameter self, you don't need to care about it because it is used inside the class. But these are the words or the parameters that you need to give for your function here. So you can see here you have the name, email, ID. These are the parameters that are required to create an employee. So let's say name equal to Muhammad. Okay, let's say the email equal to muhammad.gmail.com. Sorry, I'm talking French. And then here we have the ID equal to, you can give it integer 1 2 3 4 5 6 7, something like this. Okay, so now you are defining it. Let's just run it. Now you have created the new employee that has the name Muhammad, the email address Mohammed at gmail.com, and you have the ID 1234567. Okay, now if you want to check if this employee has been registered in your database, something, I am just saying database, but for now we are not using database, we are just creating an employee. It is always in our system, but I hope that you understand what I am trying to say. I'm just trying to give a real example so that you understand, because if you just see the words of Python code and only programming things, you may not understand why we are trying to understand these, or why we are trying to learn these, or something like this. But I am trying always to make an example with real world things that we use in our daily life, so that you understand the relationship between programming and real life. Okay, so yeah, now if I want to check if this employee has his name registered, his email and his ID, what you can do, you just need to write the name of the object, which is or the instance. Whenever we create, this is the object, and whenever we create a new employee, it is an instance. So whenever you create a new, let's say, new variable or new thing from the class that you have created, it is an instance. So we have the instance employee 1. Now if I want to print his name, I just need to do that and then put the name of the variable. So now it is name. Okay, if I run it, it is Muhammad. You should have used print, because now always we are using Jupyter Notebook, which we don't need print for that thing, but I will add print so that it will be general code for whenever you, so whatever you are using to follow the tutorials, it will be easier for you to see what happens. Now if I run this, you see that it is the employee name Muhammad. If we do the same thing for the email, it will be the same here, and the same thing for the ID. So you see, this is how it happens. Now we have only one instance, which is employee 1, and it has his name, his email address, his ID, and you can add a lot of information if you want. But these are only the variables, or only the only variables. We don't have any operation yet. So if you want to add any operation inside your function, then you can just do def create a function and give it something. And there are some functions, as I said, there are some functions that you can create them and use them inside and outside the function, the class. And there are some functions that will be called whenever you use the class out, whenever you use the class outside the class, of course. Whenever you use that, you will have the code will call them without your permission. So when, for example, this function init, now it is being called without your permission. So we are not using like employee.init and giving this. We are just putting employee, giving this in parameters. The class knows that needs to call this function init. So there are other functions the same as this one. So this one is the constructor. There are other functions that we can use them without a need to call them. So for example, if you want that, so now if I just to show you the example why we are going to do that. So let's say I want to print the employee. So if I print the employee, you will see that it will say like it is the main employee object, something like this. But it is not showing us exactly what is happening here. So if I want to customize it, I want that when I do print employee, it will print like the name, the email, and the ID. So if whenever I print the employee, it will show me this information. So you can customize that. There are two ways of doing it. You can create a new function that will take them, but if you create a normal function, then you will need always to it won't be like just doing print, which is a general function in Python, but you will need to call a function from the instance, and this function will do the print, which is not practical. If you want to say, I want that if I call the function print, which is a general function in Python, it will print the employee's name, email, address, and ID. So to do that, there is a function also reserved called str. Okay, let me just delete. These are by default created, but you can always delete them. Okay, so now we have this. If I want to do what I said, what you can do, you can just do return, and then you return the name. Let's say, for example, self dot name. Okay, so now I am returning the self.name. Let me just run this. So whenever I use the function this print employee, let's say I will redefine the employee one, and then I print it. So now I am using print, but it is not showing the like object and the index and all these things, but it is showing the name which we printed here. So now we are just printing the name. If I want to print the other objects, so I can directly add the self.email, self.id. Okay, now let's do this, and now I think, yeah, okay, I think it doesn't, yeah, I think it doesn't accept this, but what we can do, we can just add plus and add the space, and then add plus, and the same thing for the ID. Let's say plus and space and plus. What I am doing here, because I think it doesn't take the tuple, which is 3 values at the same time, but it takes only one string. So now if we want to return one string, what we can do, we create the self name, and we have a small space between it, so that we don't have only one sentence containing everything, but we have a small space here, and then we have self.name, email, sorry, and a space here, and self.id. Okay, so let's run it here, and now, okay, it is still showing this problem. Why? Yeah, I know, because this self.id is an integer. So let's just convert it into str. Str means the string. So when you have, because this one is a string, this one is a string, but the id is a integer, so it doesn't accept it for now. What we can do, let's just run it again, and now we should have it directly here. We have the name, the email address, and the id, because at the beginning it didn't work because we are giving the id as integers, and since it is integer, it will not work here because this str is already saying a string, so it should return a string. You cannot return an integer or something like this. Okay, so this is how we can define a function that will be called automatically, the same as this one. Now if I want to call another or create another function that will do an operation, let me just add another function called def. Let's say, for example, this function will print only the ID. Okay, so let's say print ID. Okay, and then we have we should have the word self, parameter self in the parameters, so that this function will recognize the ID which is inside the function, or the instance, or the same ID of this instance, because if you don't self, it doesn't recognize it. So let's say self, and now I want to print self.id. Okay, so now whenever we call this function, it will print the ID of the same instance. So let's just run it now and test it. Now if I want to do employee dot print ID, okay, now if I do that, it will show you this. Okay, now I tried a simple example, just printing the ID, which we could do directly employee1.id, but since we don't have a lot of operations that we can apply between the name, email, and ID, I just wanted to show you how it works. But this is how it works. You just need to write the name of the instance, and then dot the function that is inside the class, and it will be called. So if you have a function that has parameters, this self parameter is not counted. So if you have another parameter, let's say 1 or something like this, or you have the parameter, let's say word, okay, something like this. So whenever you call this function, you should give the parameter word, otherwise it will not work, because it has the same idea as the other functions that we used before. So if you have a required parameter, you should always give it. If it is an optional parameter, you should give it the like a default value, something like this. You should give it the default value, let's say something like this. But this is how it works. So yeah, this is all what I can say for the classes. We may see other advanced examples when we talk about libraries for medical imaging. But yeah, if you have any questions about these, please let me know. Now let's talk about the exceptions, which are the syntax, try, except, and finally if needed. So what is the role of this? Maybe we don't see a lot of people talking about this because it is not something that we use in our daily life, but I promise you, if you are working on a project, either for medical imaging or for something else, using Python, you should always use this syntax. Why? Because this is a check syntax where you are checking if your code is working or not. So for example, if you are trying to read a file to apply something on that file, and you don't know if the user will always give the right file or not. So if you don't do that, you may always have errors. So for example, if your code is expecting for DICOM files and you give a nifty file and you are not adding any check if you in your code, then you may not have the results, and even the code will be stopped because of this error, because you didn't do any check, it didn't do any exceptions. So if the user doesn't upload the real or the right format, you didn't add anything in your code that will check that and will tell the user to upload the exact file or something like this. It is the same thing as you are, for example, trying to connect in a website and it is asking for an email address, and you give a wrong email address. For example, instead of giving at gmail.com, you just give a name without any at something, at the domain name. So this is just an example. So the code will or the website will show you an error example saying that the email address that you gave is wrong, you need to change the format or something like this. So this is one example. But if you don't add any exception or any check in your code, then if the user will not give the right format of the email, then there is nothing that will tell him that there is problem with the email, but all the code will be stopped because the email is wrong and there is no checks of that for that. Sorry. So this is just a simple example of saying it, but you will see that if you are trying to work on any project, you will always need to add this checks, so that your code will not stop in small or few a few errors, but it should always show the user that there is a problem here, you need to add it, and then the code will be initialized without having errors and without stopping the code or the whole process. Okay, so the syntax for that is try. So whenever we use the word try, meaning that we are trying to do as a check in our code, or because it is not only in one line, you can check the whole code, you can check a whole process, you can check a whole for loop. So anything you want to check, you can put it inside this try syntax. So but whenever you use try, you should always add the except, because if you don't use it, you don't add the except, your code will not work. Because if you say that try doing this, but you are not adding the except, like if this doesn't work, so what the code should do after that. But if you don't give it, which is the except, so try, let's just give an example, try doing this. But if you don't add the exception, if for example the code tried to do this but it couldn't do it for some reason which we don't know, there is an error in the file, there is an error in the syntax or something like that. So if you have this problem and you don't add the except, so the code will not know what to do after. So you should add the except. So if this works, okay, if it doesn't work, you should do something else, which is, let's say, do something else, something like this. Okay, so do this. If it doesn't work, do something else, which we are just giving string, but you can give a whole process or whole block of process. So let's say you have a for loop, all the for loop, you can put it here, and the exception will be here. Okay, so this is how it works. So if for example you are not sure if the user will give only one value or two values, so you can do a block that will use only one value here in the try. But if it doesn't work, means that the user gave two values, then you can give the block to work with two values in the exception here. So if the user give one value, it will take this block, and if the user give two values, it will take this block. Okay, something like this. Now to try it, I have created this function, like my function. It is just taking a word here and printing it here. Okay, so you see that this variable or this parameter is required for this function. If I don't give it, it will give an error. So let me just show you. Now if I do my function just like this, you will have an error because the argument word is required. Okay, let me delete it. So if I am using this function inside my project, for example, and I don't want that my code will be stopped, because whenever you have an error, the code will be stopped. But if I don't want the code that will be stopped in something like this, but I just want to check if it can do this process, otherwise it can complete the job, or it can just show to the user that there is a problem, but it will not stop. It should complete whatever tasks it has. So to do that, we can just add the call to the function here. So let's say my function. Okay, so if I do that now, if I am just calling it without giving the word here, meaning that it should give an error. But for now, I am not using it just like this. I am using it inside the check. So you can try calling the function. If it doesn't work, if for some reason, so let's say print, for now, let's say that wrong call to the function, or we can add anything we want. So I am just saying it like this. If I run this, it is showing me that wrong call for my function, because the function didn't work, because we didn't give the parameter when we called the function. So it is showing the exception part. But if I give the exact thing to this, so let's say, for example, hello, I am just giving hello in the function. So if I run it, it is showing hello directly. It is calling the function and printing the word hello. And it is not showing the except, because the try block is working without any error. Okay, so this is only a small example of showing how to use try and except. But if you want something bigger, you can always put your blocks here to be checked. If it works, then okay. If it doesn't work, it will show you a error message. Or if you have another block that can work with other conditions, that you can put it here. I hope that you get the point. And there is also another keyword that can be used with the try except, which is finally. So finally is a block, like the block that you will put here will be always called at the end of the process. So let's say, for example, print checks completed. Okay, so like this. So whenever I do I call the try, it will call the try. If it works, then okay. If it doesn't work, let's delete this. If it doesn't work, it will call the except part, which is saying that the wrong call to the function, and then it will say that the checks is completed, because we did the checks. If it is working, we'll show this. If it's working, it will show the word, for example, hello. If it is not working, it will show the message here to the user. And of course, after both cases, the checks are completed. Okay, so this is how it works. If you have any questions about these, please let me know. Now we can talk about the modules and packages. So before that, whenever we worked with the classes, functions, anything like that, variables, so we always used a like normal Python syntax, that everything is already known and everything is already defined. So we didn't need to import any external module or any external code that has been written by us or by anyone else. Okay, so in this code, in this video, I will show you a small example of how to import a function or a code from an external file that is not defined by default in Python, or it is not directly defined in our code here. So if there is any function for mathematical equations, or for anything, for images, for files, for anything like that, and is not declared in your code, you cannot directly use it. You should either install it or call it or something, or write it inside your script or in Jupyter Notebook, something like this. But if you have, like, especially whenever you use external packages that you didn't write yourself, so you need to import them. So there are some packages that are already installed with Python, but you cannot use them only when you import them. But there are some packages that are not even installed in your Python environment, so you need to install them first. So for now, let's talk about the packages that are already installed with Python that doesn't need to be installed. So to do that, you can just come here. For example, let's take the module math, which is for mathematical operations. So to import any module, you can write the keyword import, and then you write the name of the package that you want to import. So for us, it is math. So now we are importing math, which means that we are just importing the let's say the main object, which is math, but we are not specifying which exact operation or exact function we are trying to import. We are just importing the math, and after that we can, using the word or using the package math, we can call the other functions or other variables or something like this that are declared in the package math. But if you want to import a specific package or specific thing from math, you can do from math import and then the name of the package that you want. Okay, so depending to how your function is or how your package is defined. So if your let's say this math is defined as a file, so if you have a file called math, and inside this file you have functions, you have classes, and you want to import one class or one function from the package math, then you can do it like this. But if your math is already a class or a function, this means that you cannot just import a variable from a function which is declared in another file. You just need to import the whole function or the whole class, and using this class, the same thing as we have here. When you have the class, you can do class dot the name of the function or class dot the name of the variable and something like this. So now we are just importing math. Okay, let's run the cell to import it. Now it is imported. Let's do a simple mathematical operation. So let's say x equal to, we want to calculate the square of value, let's say 25. Okay, so we have math, then that we call the function sqrt. So now we are calculating the square, and now we give the value, for example, 25. Okay, so you can give anything you want. I will just run it. Now let's print the new value, which is x here, and you see it is 5. So the square of 25 is 5. Okay, so you can do the same thing for any other operations. There is the cos, there is the sinus, there are a lot of things that are defined in the math, and this is just to show you how it works. And you can see that we are doing the same thing as we use the functions, the classes and the functions, of course, both of them. So we are just giving the instance which we imported here, and then we are calling the function that will calculate the square of the value given in parameters. And now we are having the value 5, which is the square of 25, because we have 5 multiplied by 5, we have 25. Okay, so this is how we can import a simple package, and we can do this for all our code. And you will see that all the time you will import packages, because most of the packages or most of the code that will be used for either medical imaging or to treat files, images, anything like that, you should always import other packages that has been written by other developers, and you can use them for your code. So yeah, let's stop this video here, and we can complete with other examples in next videos. So after seeing how we can import a package or external package and use it for our code, now I will show you how. I will give you an example of 2 libraries, let's say, that are very, very useful in your code, and you will use them all the time. All the time you will use them. The first library called OS, operating system, and the other one called glob. So especially OS, it is always used. I have never seen a code that doesn't use OS. I am not saying that 100%, but let's say 90% or 95% you will need to use the OS library. So OS library is also already installed with Python, so you don't need to install it. You just need to import it. So let's say import OS. Okay, now you may say why or when we will use this OS library. I will give you just a few examples, and you will understand that it is very useful. We use it for a lot of things. So the first thing, which is always used for, which is creating a directory. So if you want to create a directory, and you have a code and it is running automatically, and you want to create a directory whenever you are running a process, because you don't need always to create them manually. So for example, if you are creating new files and you want to put each file to in a directory in each time you create it, yeah, and then you need to create the folder all the time, or maybe set of folders. So you have folder inside a folder inside a folder. So it depends to what you want to create, folder or a whole path. So whenever you want to do that, you can use the function or the library OS. Of course, there are other libraries, but the most used is OS. So for example, I want to create a directory here in my my workspace here. So what I can do, I just need to put os dot make dirs. So when I use make dirs, I can give the name of the folder, for example, test. And here you can give a folder, or you can give a whole path. So you can give test.test2.test, let's say 3, something like this. You can always do that. Let's start by a folder. So now if I run it, you can see that I created a folder called test. Okay. Now, if I want to run this again, you will see that it will give us error, because the folder test is already existing. So if you want to avoid this problem, what you can do, there are two ways. The first way, which is you just add a condition to check if the folder exists or not. To do that, you can do if os.path.exists. So this function path.exists will give you the ability to check if a path or folder exists or not. So if you give here test, okay, now it will check if it exists or not. So if it doesn't exist, then you want to create the folder. But now you are doing if it exists. But if we want to know if it doesn't exist, the directory here, we can create the folder. So how you can do that? If not means that the reverse of this. So this function will return true if it exists. So now we are reversing it. If not exists, if it doesn't exist, then make the directory. So now let's run it. You see that we don't have any error, and the folder is not it is already created. But now let's say if I want to have another folder called test1, and here we can add 1. Okay, now it has created the new folder because it exists here, but it doesn't exist, sorry. So we have to create it again. But if I rerun it now, since the folder is already existing here, I don't need to create it again. But you can directly resume all this instead of using the condition and all these things. You can directly, whenever you use this function, there is another parameter that you need to check, which is exists. Okay, then this you put it true. So whenever you put this parameter, this argument into true, means that if the folder exists, you don't need to recreate it again. So let me just delete all this and this. Okay, now if I run this, now it doesn't give error and the folder is already created. If I do, for example, test2 and I run it, it will create the folder. If I rerun it again, it will not give any error and it will not create the folder again. So yeah, this is one of the examples. If, for example, you have multiple paths, so let's say, for example, path 1 equal to my dir, for example, and I have path 2 equal to files. Okay, and this path 1, it can be, for example, like C directory, and then you have user, you have, and something like this. This is how you can, for example, have the first path. And the second path, it can be also a path, or it can be only the name of the file. So for example, if you want to create a new folder in a specific directory, and then you want to put your files inside that folder, for example, then you need to create the whole path, the path that has c/user/mydir/files. So there are two ways of doing it. There is the simplest way, which is just doing path 1 plus, and like you use it as a string, and then plus here the slash, and slash and plus the path 2. Okay, you can do it like this, but the idea here, if I not define. Sorry, we didn't run this cell. Now let's run it. Okay, so now you can see that you have C, user, my fold, my dir, and files. But this is not the best way of doing it, because this is not general. We are just putting it like, because we know that we want the part 1 and the part 2. But if you have a code that will create always new paths that you cannot control all the time by a string operation, so what you can do, you can directly use the library OS. So OS can create the new path for you using a function called join. So here you have os.path. So we are working on path, so we need to go to the to the let's say class path, and then you have the function called join. So this function called join, it can take as much as parameters you give. So let's say path 1. Now, when I am saying path 1, I am not talking about this because it is a string, but just to give multiple paths, path 3, path 4. Okay, let's just stop here. So we have path 1, path 2, path 3, path 4. So these can be all of them paths, or they can be only directories, and you want to combine them to create a new path. It depends to what you need. But this is how we can, for example, give multiple paths or multiple strings inside the function join. And if I run it, you can see that we created automatically the new path that combines all of them. Okay, so this is how we can directly create new path using the library OS. And here we have everything set. If you want to do the same thing for other type of paths, if you have a loop that is automating things and you want to create a new path in each time, you can do this as well. And the same thing for other, there are a lot of functions. I cannot talk about all of them now, but I want just to talk about another one that I used all the time, which is base name. So for example, you have a path and you want to extract the name of the file or the last part of the path. For example, we have, let's say, path 4, or let's say file.dcm. Let's say this is a DCM file. And for me, I want to have the name of this DCM file that I will use to create a new file, JPEG file or something like this. But for me, I will need to know maybe the extension, or maybe I will need the file name or something like this. What I can do, I will need to extract this. There are also another ways to split the string here, which is, this is all one string. You can split it directly and take the last part, but this one for most of the time you may not know, because to separate the path you can either have two slashes, like two backward slashes, you can have forward slash, you can have things that you cannot control most of the time. So what you can do, instead of trying to discover if the path contain forward slash, backward slash, two forward slashes or something like this, what you can do, you can directly use a function called, let's say, os.path.base name. So base name will return the base name, which is the last name or last part of the path. So now before that, let me just create a new path equal, because we don't have it saved in some part. But and you see here we are using the variables, and we are assigning the new path created here to this variable, and we can use it after that. So we can see now we are trying to use the things that we learned before, because when we saw variables we didn't see where is the use of them, functions also, but now we are trying to apply them, classes, everything. We are trying to apply them in real world problems. I hope that you are getting my point, but all the time I say, if you have any questions about all these things, you can always leave a message, either private message, you can post it in the community, you can send me email, you can choose anything you want, easiest for you. Okay, so now you have os.path.base name, and now we can put the name of the path, which is new path, for example. So now if I run it, we have the DCM, the file.dcm. Okay, so you see here how we can use the os.path.base name to return the base name of your path. And also this function we will use it sometime in our code, but I just wanted to show you. And Also, there are a lot of paths, a lot of functions inside this OS library. There is the rename, there are a lot of things. But for now, I just wanted to talk about the ones that I use most of the time, which is the join, base name, and create a directory. Okay. So now, after talking about this, let's talk about the library glob. This library glob has only one operation, that is, it may have other operations, but most of us use one operation that will be used always for the paths. I will show you how to do that, but before that, you need to know that glob library is not already installed with Python, so you need to install it directly in your environment. So now we are always in our Python for medical imaging environment. If you want to install any package or any library in Python, then you need to come to your terminal and press, like, you just put pip and then install, and then you put the name of the package. And you need to be careful, because sometimes the name of the package that you use in your code is not the same name that you use to install. So for example, the glob, when we use it in our code, we just import glob. But when you want to use it, or you want to install it, you need to put glob 2, because if you put glob without the 2, it will not be recognized. The same thing for other packages. For example, you have OpenCV. When you use OpenCV in your code, you just put CV2, but when you want to install it, you need to put pip install OpenCV Python. So you need always to check before installing anything. You need to check if the name is the same name that we use in our code, or it is this different. Okay, so now let's say pip install glob2, and let's press enter to install it. Okay, now it is successfully installed. Now let's go to our code. Let's import it, import glob. Okay, now we imported glob. I will show you one feature that I always use in our code, and yeah, and you will see that this is the only features that you will use most of the time. You don't need other things, but let me just show you. So the glob function, what is the role of this glob function? It will return whatever you have inside a folder. So if you have folders, if you have files, if you have anything inside the folder, you can return it as a list. So this is the role of this. But before that, let me just create, let's say here, let me create folder 1, and then in test, let me create folder 2, something like this. And here, yeah, okay, let me just leave it like this. Okay, now if I want to return the folders that are inside the folder test, okay, so what I can do, because it will not just return the folder, but it will return the whole path to that folder. Okay, and yeah, to do that, let's just come here and use let's say folders, or yeah, folders path equal to glob, and then here the glob function is not, because the name of the library is glob, but to use a function to return the paths, there is another function called glob. I don't know why they put it like this, but it is like this. But for me, most of the time I don't use glob.glob, but whenever I import it, I do like this: from glob import glob. Okay, so now I can directly use glob without glob.glob. I directly use glob, and I give it the path here where I have files, where I have folders, and I want to return their path. So what I can do, I need to give the path to the folder, which is here test. Okay, but now if I just do it like this, it doesn't recognize what I want to do. I am just giving test. So if I run it, now we have print folders path. You can see that we have only test. We don't have anything returned because we just gave the test. But if I want to say that I want to return the path to everything that is inside the folder test, so to do that, you can come here and add the star. Star means everything. So everything that is inside the folder test, I want it to be returned. So if I run it now and I run it again, you will see that we have a directory that has two folders, two paths, sorry. The path 1 to the folder 1, the path 2 to the folder 2. And if you have files, so let's say, for example, I want to add a file here, file.txt, for example. Okay, now if I run this code, again. You need to know that you need to run it again. And now you see that we have the file.txt, we have the folder, and we have the folder. Now, and you can see we are returning everything, folders, files, and everything. If I want to return, for example, only the txt file that are in this file, in this folder, I don't want to return the folders, or I don't want to return the PNG file or something like this. Maybe your code is expecting only txt files. So what you can do, you need to specify the extension. So you can put here everything.txt. So if you do everything.txt and run it, now you will see that it will return only the file that has the extension txt. And you can do that the same. You can do the same for other extensions like .jpeg, .dcm, for icon file, .nifty, everything. So now we are checking that your list of paths contains only the desired file format that you want. So this is the example that I showed, and you will see that we will use it all the time, this globe function, because it helps us a lot to return the path to the files that are needed. So if I need only DCM, I need to return only DCM. I don't want to create a loop that will pass by all the folders, all the files, and everything else. I just want to return a list containing the paths to the DCM files. So yeah, this is how it works. And if you have any question about this or about OS, of course you can leave them in the comments, and you can check also the documentation of these libraries. There are always a lot of examples to explain how it works. So see you in next videos. Now let's talk about the most important library in Python for data scientists, which is NumPy. So NumPy is used everywhere. So even if you don't use it directly in your code, it is being used in the backend. So any library that treats arrays, treats images in the backend, we are always using NumPy, because for this reason I'm saying that it is not one of the most important, but it is the important library in data scientists domain. So whenever you use images, arrays, whenever you use like neural networks, all these things, you are always using NumPy, like either in the front end or in the back end of your code. It is always being used. For this reason, I wanted to talk about it. I cannot talk about all the operations available in NumPy, because this will take us 1 month talking only about NumPy. But most of the time you can find all the documentations online, and in Stack Overflow you will find always solutions. So it is very easy to use it. I will just give you small few examples that can help you start working with NumPy. But whenever you are doing a project and you need more advanced things or more advanced operations that are not used always with NumPy, you can always find them and use them for your code. And it is very easy to use NumPy. You will see, I will give you a few examples, but you will see that it is the same way whenever you want to use another library or another function, or another operation. It is the same principle always. Okay, so before that, I think it is not installed in our environment, so we need to install it. To install it, we just need to go to our terminal. We need to activate the Conda environment that we have, which is Python for medical imaging. So to install a library, as we said, we need to press pip install and then the name of the library. So for us, it is NumPy. So like this. So pip install NumPy and then press enter. It is being installed. Okay, so yes, we have successfully installed NumPy. Now you can import it here. So import NumPy as NP. So we use NP just to make it easier for us to use it. And by convention, they use NP. So whenever you import a library, you can always import it with another sub name if you want. So you can just import it as N. And whenever you want to use NumPy, you need just to use N. But like N is more general. For this reason, we should preferably use 2 characters, 3 characters, something like this. We don't need to use only 1 character, because maybe you will need it in the code. So that you don't want to get confused between name of variable or name of a function and the name of the library that you imported. And as I said, by convention, all the time we use NP for NumPy. So anyone who will read your code and see NP will understand that you are talking about NumPy, even if he doesn't see the import, he will understand that you are talking about NumPy. Okay, so now we have imported it. Let's run it. Now the first thing that we can do is to create an array, because most of the operation that will be used for NumPy are for the arrays. So creating array, doing some operations on the array, like most of the time we are working on with arrays, and these arrays can be considered as images or as 3D volume. All these things can be considered as a NumPy array. Why I am talking about this now? Because you will see in future videos when we'll use medical imaging. So whenever we use DICOM files, we use Nifty files, you will see that whenever you take these files, inside them there is a NumPy array. You will understand why. For this reason I am trying to explain now, and some operations that we may use in our next videos. Maybe we don't have time to explain them all the time, but now we are trying to explain in general what are these operations. So whenever we use them in our code, you will understand from where we get them, why we are using them, and what is the role of each function. Okay, so yeah, now let's declare a first array, which is a 1D array. Okay, so a equal to np dot array. Okay, so here is how we declare an array. And then you need to understand that whenever you want to create a new row for an array, you need to have the brackets. Okay, so whenever you want to create a new row, you need to put the brackets. So now we have only 1D array, which means we don't have multiple rows. We have only one row or one column. So what we will do, we just need to have one bracket, and inside it we give the values of the array that we want. So for example, 1, 2, 3, 4, 5. Okay, so now if I want to show what is this array that we declared, so we just put print a, and when we run it, we have an array of 1D, one dimension, and it is 1, 2, 3, 4, 5. Okay, so this is how we declare an array with one dimension. If we want to do with 2 dimensions, as we said, whenever we have a new row, we need to have the brackets. So when we have 2 rows, we need to have 2 brackets. But since they are the same array, then we need to put everything inside one bracket. Let me just show you how we do that. So for example, b equal to np dot array. So the container of the array should be inside the bracket. So inside the bracket we should put everything. So if it is only one row, as we had before, we just write the values. If they are 2 rows, we need to put the 2 rows. So the first row will be something like 1, 2, 3, 4, 5. Okay, this is the first row, and now we will declare the second row, which is, for example, 6, 7, 8, 9, 10. Okay, so this is our 2D array. If I run it now, we can, let me just add the print directly here, print b. So now you see we have an array with two rows, the first row, which is this one, and the second row, which is this one. So we can do the same thing to create a 3D array or 4D array, 5D, etc. So here, how we can do the same thing. If you want to do a 3D array, you can just come here. So if I want to just add another, because this is only 2D array, because we have 5 by 2. So if I just add here, for example, let's say this one, 11, 12, 13, 14, 15. Let me add this. Okay, so now what we have always we have 2D array, but with the dimensions 5 by 3. Okay, but if we want to have a 3D array, then this all thing will be one dimension, which means all this will be one slice, because this can be represented as a slice or as an image. If you want, you can convert it into image. And here is how we represent it. This is one image, because when you have an image, you have pixels. So this is an image of 5 by 3, very, very small image, but just for representation, we have an image of 5 by 3 if you want. And these are the values of each pixel, okay? But if you want to put it in 3D, so you need to create multiple slices as this one that we have. So you will have the first slice, second slice, third slice, etc., etc. I think you get the point, because we don't have to write all the dimensions, so we can just write 1, 2, 3, only 2 dimensions, and I think you get how to create the 3 dimensions. And you will see when we work with the Nifty files, you will see that the Nifty file contain a NumPy array with the 3D dimensions. So it has multiple slices, because this is, as we said, this is one slice, and a volume contain multiple slices. So you will have multiple slices like this, but of course it will be bigger one, like 512 by 512 or something like this. And it is duplicated multiple times, not duplicated, but you have multiple slices like this one, and each slice represents one 2D image of the scan that you have. Okay, so this is how to declare 1D or 2D arrays. Now let's do some operations. Let me just create here NumPy operations. Okay, now we can, as I said, there are a lot of operations that we can discuss, but I will just take few of them which I used like multiple times, because there are some operations that you can use only one time in a project or one time in your life, we don't know, but there are other operations that you will use all the time. So I just pick a few of them that I use all the time, and why I am picking these specifically, because you will use them, or you will need them for this course. So most of them we will use them in this course, others can be used in other courses. And yeah, you will see that for now I'm just going to explain them or to show them, but in future videos you will see where we use them exactly in the code. So let's say the first operation that we will discuss, which is the transpose. So whenever you have a matrix and you want to calculate its transpose, you just take the whole matrix and do some operations, which I will show you just now. And then you will understand how we code it, because if you don't understand the logic of the matrix and how we calculate the operations, you may not understand when and where you will need to calculate the transpose or any other operations. Because most of the operations that we'll use for matrix or for arrays, you will see that you will need them for images. So whenever you have an image, you want to do a rotation, you want to transpose it, you want to do any operation like that, you will need these functions. So before explaining the functions, I just wanted to explain the theory behind them. So to explain how the transpose of a matrix can be done, let's just declare a first matrix called A, for example, and it is 3 by 3. So let's give the values 0, 1, 2, 3, 4, 5, for example, 6, 7, 8. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8. These are the values of our matrix. It is 3 by 3. Okay, so now we want to calculate the transpose of this matrix, which is A superscript T. So now we are calculating the transpose of this matrix. So there is only one theory that you need to understand, and whenever you understand it, it will be easier for you all the time to calculate a transpose of the matrix. Maybe some of you already know how to calculate this, so please just skip this 1 minute, because I am just trying to explain everything for anyone who doesn't understand this. But if you are already familiar with these operations, then please just skip this 1 minute and go to the next part, which is the coding part. Okay, so now what we can do, as I said, there is only one theory, which is whenever you have rows, all the rows will be columns. So we have, this is the first row, it will be the first column of your new matrix. You have the second row, it will be the second column. and the third row, it will be the third column. So this is how we can represent the transpose of a matrix. Then, now let's calculate the exact values. So as we said, we have the first row, it will be the first column. So we have 0, 1, 2. And the second row will be the second column, which is this one. So we have 3, 4, 5. And the third row will be the third column, which is 6, 7, 8. Sorry, I just need to fix it. Okay, so now you see we have the new matrix, which is the transpose of the matrix A, and you see all what we need to do is transposing the rows into columns. So now let's go to the coding part. So for the coding, we'll do the same thing. We'll just declare one matrix, which we can maybe even use the matrix, this one, which is B, the matrix B that we have already, and we can use it to calculate the transpose of a matrix. So we will calculate the transpose of B. Okay, so transpose of B, let's say for example TB, which is transpose of B, equal to np dot transpose. Okay, so there is always functions. So for the transpose, it is already called transpose, and then we give the matrix in the parameters, or the array in parameters, the array that we have, which is B. Okay, so now we will calculate the transpose of B. Let's just calculate it and then let's print it, TB. Okay, let's just run it, and you can see here we have these are the rows. All the rows became columns. So we have 1, 2, 3, 4, 5. Now it is 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. It is here, and the same thing for the 11, 12, 13, 15, 13, 14, 15. It is here. So you see, this is how we calculate the transpose of a function, sorry, of a matrix or an array using NumPy. And we can do the same thing for other operations, like if you want to calculate the reverse, you calculate anything you want. So we'll take another example, which is to calculate the rotation of a matrix. Now we are saying rotation of a matrix, but you will see that you will use it for the images. So if you want to rotate an image, or yeah, of course, most of the time it is rotating an image, or rotate a slice of your DICOM files, or slice of your scan. All these things, whenever you want to do them, you can always use NumPy. So if it is an image, there are some operations already existing that in Pillow, in OpenCV, a lot of other libraries that treats images. But if you look in the backend of these libraries, you will see that they are using NumPy. Okay, but if for your case you are just working with arrays, you are not converting them into images yet, so we can directly do the rotation, for example, using using NumPy for some operations. And for the transpose, for now, maybe you will not see its role in this course, for example, but in other courses we may use them, because for the training, for example, if you are doing a neural network for training your model for segmentation, let's say, and most of the time the output that you will get will be transposed than the real image. So whenever you have the CBCT scan, or you have a scan, CT scan, CBCT scan, you have MRI, you have any type of scans as an input, the output will be always transposed, because whenever you convert the image or the slices into a NumPy array and you convert them into the proper format for the training, the images will be transposed. So you need always to do some reversing the transpose and doing some rotation to get the exact output. For this reason, I am just talking about them now, but you will see that in your projects, you will always need this kind of operations, okay? So let me just talk about the rotation. So we have this this matrix, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15. So this is our matrix, and I want to do the rotation. As I said before, going to the coding part, let's do the theory, and you will understand how the rotation will happen, and then we do the coding part. So here we have the matrix M, which is the same matrix B that we have in our code. 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15. Now, if you want to calculate the rotation of this matrix, you need to consider it as you are doing a rotation of a normal image or like anything that you can do rotation for. So whenever you have a box, for example, let's say you have a box like this, and you want to do the rotation, so you will just take this part and like just change the dimensions of change the positions of these points, okay, with a specific direction and specific angle. So the same thing will happen in the matrix. Let me just delete this part here. Okay, so you need to understand that, as I said, it is the same way or the same theory of doing rotation of any object. So we have here the axis X and Y, okay? And now you need to consider that this is 0. We have always 0. So whenever we are working with angles, this is the 0. And this is the positive stance, let's say. This is the negative stance. Sorry, minus. This is the positive stance. This is the negative stance. This is the 90 degree. This is the 180 degree. Okay, and if you go from this way, this is minus 90 degree, and this is minus 180 degree, and the same thing. Okay, so now for us, we will use the function called rot 90, which is rotating the image by 90 degree. So when we want to do this, we will just take the image or the array, if you want, from this direction into this. Okay, so we are calculating plus 90 degree rotation. Okay, so when you have this matrix here and you want to do the rotation by 90 degrees, so what you can do, you can just rotate it like this by 90 degrees. So what happens, you will have a matrix. Since it is here like 5 by 3, it will be 3 by 5 because we will reverse this matrix. So it will be something like this. Okay, and everything will be reversed. So we will have 5, 10, 15. These here will be this. Okay, and the same thing for the others. So we'll have 4, 9, 14, and we will have 3, 8, 13, and we will have 2, 7, 12, and the same thing for the last, which is 1, 6, and 11. So this is the rotation, let's say rot 90 degrees, for example, equal to this. Okay, it will be the same values. Of course, we are not changing any values. We are not calculating the reverse of a matrix or something like this, but just we are rotating it. So it was like this. It was this one, and we convert it into this one. So this is what the code will do. And if you have an image, you have a vertical image, you want to convert it into a horizontal image, so you can just apply this rotation. It will be rotated. Same thing if you have the reverse. So this is how we say, when we say a rotation, this is what happens. So consider that this is an image and it is rotated horizontally, and you want to convert it back or rotate it back into vertical. So you can apply a plus 90 degree of rotation, and it will be this one here. So let's go to the coding part and see how we can do it. So as we said, we have the matrix B, which was matrix M in our theory, but it is the same matrix because it has the same values as you can see here. Now let's calculate the rotation. So let's say rot 90 degree of B. Okay, it is equal to np dot rot 90 degree, and then here we give the matrix B. Now let's print it. So print rot 90 degree B. Okay, so now you see that we have the same thing that we found, which is 5, 10. Sorry, we have something. Yeah, we have 5, 10, 15, and the same thing for all the values as we have seen in theory. So you see that whenever you have an image or you have an array in general and you want to rotate it by 90 degree, you can use this you can use this function, which is rot, which is for the rotation. And you will see that we can do the same thing for other operations, such as calculating reverse of a matrix, or even doing rotation with a specific angle, because here we are always doing the rotation with the 90 degrees. But if you want to do rotation with a specific angle, always there are functions for that. And you should, if you want to practice your coding skills, you can always try these functions and see how it works, and you can make the relationship between the theory and the code, and yeah, you will understand what are these functions and how it works. This will help you to use them in your projects. Okay, so this is how we can do the rotation. Now let's go to other operations that I use also all the time, which is, for example, calculating the minimum of an array, calculating the maximum of an array. You will see that, yeah, it is easy to understand now. But if you have a volume with, like, let's say 500 ml, 500 by 500 by 500, which means like you have 500 slices, and each slice has a dimension of 512 or 500 by 500. So imagine with me how many values you have. So if you want to calculate the minimum or the maximum, especially if it is a NumPy array, like, you cannot just do that manually. You need always to have a code, and you cannot also calculate it by a loop, like creating a loop that will pass by the whole matrix or the whole array and find the minimum, because this is not like a stupid way to do it. But there is always functions, especially for example for NumPy, there are always functions for all the operations that we will need most of the time. Okay, so imagine you want to calculate the minimum of the matrix B. So let's say min of B equal to np dot min, and then here we give the B. Okay, and the same thing if you want to calculate the max. So let's say maximum of B equal to np dot max B. Now let's print them. Print min B max B. Okay, now let's run this cell here, and you can see that the minimum is 1 and the maximum is 15, and it is the same, the right thing that we need. So you see here, if you have like a big matrix and you want to find the minimum and the maximum and do some operation with it, which we will use already in this course, then you need to use this np.min, np.max, and it will return the minimum and the maximum. And always for all the functions of NumPy, which is np, there are always parameters. So for us, for example, we are using, or we are taking the minimum parameters, or the minimum number of parameters, which is only giving the array. But if you want to calculate, for example, you want to do the rotation by minus 900, minus 90 instead of plus 90, so there is a parameter that you can activate. And the same thing for the minimum, for the maximum. Most of the time there are always other parameters or arguments that you can use them for a specific type of conversion or something like this. For us, we are just taking the easiest way, or we are just taking the minimum way of using these functions. But as I said, if you want to know more, you can always check the whole documentation, because if we want to record that, it will take 1 month talking only about NumPy, which is not the subject of the course. Okay, so yeah, this is how to calculate the minimum and the maximum. Now, for example, I want to show you another function that I use also all the time, which is unique. So this function called unique, it shows, or it gives you the values, or how many unique values you have in your matrix. So for example, let's say you have this matrix. Okay, so if you want to know how many unique value we have here, as we can see, it is 5 by 3. It is 15 unique value, because we don't have any value that is repeated in this array. So we have only 1 of 1s, 1 of 2, 1 of 3, 1 of 4. We have always one let's say one value, each value we have only one index. Okay, so if I want to return something like this, because you will need this type of operations if you want to know how many let's say you have a mask of an output of your model, let's say, and you want to see how many classes your model has segmented. So you can see if it's segmented only one, only the background, for example, it will be, the unique will be only 0 because the whole image will be black, so we have only 0. If you have it's represent, or if it returns two values, which is 0 and 1, meaning that you have only one class. If it returns three values, so you have, for example, 0, 1, 2, so you have three classes or three indexes. So this is, most of the time, this is where you can use the function np.unique. Okay, so let me just show you an example here. Let's say unique b. Okay, now we have np.unique, and then here we give the matrix that we want, which is b. Okay, now let's print it, print unique b. Yeah, so now we don't have any reversed value. We have all the unique. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are the unique values. We don't have anything else, but yeah, this is how we can represent them. But now, if, for example, I want to know how many values we have, for example, for how many ones we have in the matrix, how many, like the counting of these unique values, so you can do that also. You can just have here, there is another parameter called return count. Okay, when you activate this as true, it will return the counts of your values. So let me just give here the counts. Okay, let's just run it. Now if I want to print the counts, now you see it is 1, 1, 1, 1, 1, because all these values we have only one time of them, so we have only 1, 1, 1, 2, etc, etc. So, and you can see this is only two parameters. There are other parameters. If, for example, you want to return the index of each value, for example, you want to return the index. When we say the index, I am talking about the position in the matrix of this value. So if you want to return where we can find this value, which is 1, it will give you the indexes for that. So you can just know where is it, and you can use it for anything you want. Okay. So yeah, this is how to return also the counts, or the uniques plus the counts of how many values we have, or how many different values we have in our matrix, and how many times it is repeated in the matrix, and all these things. So for NumPy, I will stop here because, as I said, we cannot talk about everything. But these are the most important ones that I use all the time. But of course, there are also other operations that also I use all the time. But as I said, there are a lot of them. But I will just keep them here. And if you want, you can always check documentation for more information about these libraries. So yeah, this is about NumPy, and let's complete our course for other libraries. Now we can talk about another library called matplotlib. So this library is like one of the most used libraries in computer vision. So it has multiple functionalities, but the most used one is visualization. So we use it to visualize graphs, to visualize points, to visualize images, to visualize multiple things. So here, and it is also used a lot in the medical imaging field. So it helps us to visualize the image and the mask if we are doing segmentation, to visualize the image in multi dimensions. So for example, if we want to show the same patient, if you have a case, medical imaging case, let's say for example an MRI or CT scan, and we want to show or to visualize the three axes at the same time. So let's say XYZ, which is the axial, coronal, and sagittal. And when we want to do this, what we can do, we can directly show the three images at the same time at the same figure. So this we can do it using matplotlib, and there are a lot of things that we can do using matplotlib. These are only few examples, but I will show you just how to display an image, or how to display three images at a time. So for example, if you want to visualize the axial, coronal, and sagittal axes at the same time, you can do it as well. So let me start with visualizing only one image, and then we go to multiple images. And of course, since we are using matplotlib, it is a library that needs to be installed. So you can install it using pip install matplotlib. So for me, I will not install it again because I have it already installed in my system, but you can directly do pip install matplotlib and it will be installed. Okay, let me delete this. Okay, all right. So yeah, let me just start here. So you will see that it will be very easy to use matplotlib for visualizing images. So let's start by only one image. To do that, let's import the function that we will need, which is import matplot, sorry, dot pyplot as PLT. So PLT is by convention. So most of the let's say the programmers use PLT by convention to specify that we want to import the pyplot from matplotlib. So when we do import matplotlib.pyplot, so we are importing pyplot in reality, but we are assigning the name PLT just to be easier instead of using all the time pyplotlib, pyplot. So for the system, we are just putting PLT, so that will be easier. Okay. Now let's start reading the image. So to read an image, you can directly do emg, for example, name of the variable equal to plt dot read, and here we give the path to the image. For us, it is, for example, data slash sample1.png. So here we are reading the image, you see, but we are not doing anything with the image. We are just reading it. If we want to display it, then we can do it easily here. Let's do it here. So for example, we have plt dot show, and here we give the image, and here we need to specify what is the image map. So for example, it can be RGB, it can be grayscale, like gray image. There are multiple codes that we can give. Most of the time when we use for medical imaging, since the images are, most of them are grayscale. So when we have like MRIs, CT scans, CBCTs, like most of these images are gray scales. So we can do CMAP equal to gray. Okay, but of course, this is only one example for this kind of images. If you are using different type of images, if you are, for example, using like colored images, so you need to change the parameters. Because here I am not going deeper for each library. I am just taking fewer examples so that you can start with it. And after that, you can do whatever you want with these libraries. Okay. So here we specified the type of image, which is gray. Now we can specify also the title of the figure. So here for the title, let's say 2D image, since it is only one slice. Okay, and then here after specifying the title, we can directly show it. So because if I just run this, you can see that we can visualize it here. But if you are using a Python script directly like this, and you run this code, you cannot see the image. You should add the plt dot show. Okay, if you don't add this when using a normal Python script, because here we are in Jupyter Notebook. If you are not using Jupyter Notebook and you don't add this, you cannot visualize the image. Okay, so yeah, I will just leave it here so that you will know. But in the future, if you are using like a Python file, you need to add this line here. Otherwise, you cannot visualize the image. There is no error, but you cannot see the image. Okay. Now, after doing this, we can do multi-image visualization. So for example, if you have 3 images, you have or you have a 3D scan, and you want to visualize the axial, coronal, and sagittal slices at the same time in one figure, you can do that. For me now, I have 3 images, which are these. They are not corresponding to the same patient and the same case. But I am just taking these 3 images and visualize them, and you can see that it is the same thing. Since you have 3 images, you can all the time visualize them with the same way that I will show you here. So the same thing, you will need to import this, but if we already imported it here, you don't, since we are working on Jupyter Notebook here, you don't need to re-import it again because it is already imported. And yeah, that is the numpy which has to be imported. I didn't import it. I have already imported it here, but since we didn't rerun the cells, then the this library is not imported. You need to rerun the cell again, but I am just putting it here so that we know that we are using NumPy and pyplotly. So matplotlib, sorry. So here, after doing this, after importing the NumPy, we can start importing the images. And if you have already a 3D image, so you can directly specify by doing the vectors. So for example, if you have, let's say, image 3D, if it is a NumPy array, for example, if it is like it has 3 dimensions, for example, it has the X, Y, and Z. So if you want to specify the axial is the Z axis in reality. So axial axis, for example, equal to the image 3D. And if you want to specify the Z axis, so you can do everything, and then, for example, because when we say everything, meaning that we are taking all the x's, all the y's, so all the x, all the y, but we are specifying which slice. So here we can say, for example, 0 to specify the first slice. If we say 1, second slice, etc., etc. Okay, so here, if we want to take the axial, if we want to take the coronal, we take these. If we want to add the sagittal, we take these. Okay, but since for us we don't have a 3D image, we have 2D images, so we can import them independently. Okay, so to do that, let's just define, for example, image 1 equal to, and we can directly read it, so plt dot imread, and here we give the path to the image, which is like data, then slash image 1, and we do the same thing. So we have emg2 equal to image equal plt and sample 2, but here I think the second image is gpg, not png. And this third image, which is this one, I don't know why I am keeping writing this. Okay, so, but this one is PNG. Okay, so now we have the 3 images. Let me just run here. You see that we have already imported or read the images. Now, the second thing that we need to do is defining the axes. Since we said that we'll have three images. Okay, so we'll have 1 row and 3 columns. So we need to define the figure and the different axes, which are the rows and the columns. Okay, and of course the figure. So here we have fig for the figure and axes. Okay, equal to plt dot subplots. Okay, when we say subplots, we are like, I didn't spell the plt right. Okay, what I am doing, plt dot subplots. Okay, so now we are defining the different axes, which are the xyz, but here we said that we want 1 row and 3 columns, and each column will contain 1 image. So to do that, let's put 1 for 1 row, 3 for 3 columns, and we can also specify the fig size, which is the size of the figure. For example, we can say 10 by 5. Okay, so this is how we are splitting the axes. Now we can like put, for each axe we put 1 image. Since we have 3 images, so we will put them there. And also we can specify the title so that it will be easier to define which image is there. Okay, so for example, we have the axis 0. Okay, axis 0 for the first axis. So we have we can directly do axis 0, which is the first one, like show, and here we put the image 1. Okay, then comma, and we specify the CMAP equal to gray. Okay, and we need to do the same thing for the others, but before that we need to specify the ax title. So axis to of 0, and then set title, and then here we give the title, for example, let's say image 1. Okay, and we do the same thing for the other axes and other images also. So let me just copy this, it will be easier now. Here we have 1, and here 1. The same thing for this, it should be the second image. Okay, and here second image, and the same thing for the third image. Here it should be 2. We are writing 2 because we are the indexes of the images start from 0, so 0, 1, 2 means that the third image. And here we say image 3, and the same thing here, image 3. Okay, so now we should have all of them. If we run this here, you see that we have the 3 images, and the same thing here. If we are not adding like plt.show, but it is working. But if you use the normal Python scripts, you should add it here, otherwise you cannot see these. Okay, so let me just add it so that you will remember it. Okay, now you can see that we have 1 row and 3 columns. Each column is representing the image. So if you have like a 3D image or 3D patient, and you want to show like the 3 axes for each index, so you can do this directly, and you can see the study of your patient, and you can see like if you have a tumor, for example, you can see it in the X, like here, this is the Z axis, but let's say like in the X, Y, and Z. So you can directly see the same object or the same tumor, the same pathology, the same organ at all the 3 axes, and it will be easier for you to identify where is the, for example, if you are doing segmentation, so you can directly see where is the organ, for example the liver, and you can directly see how to segment it in the 3 axes, for example. And if you do have the image segmentation, so for example, if you have the scan and you have the segmentation of the scan, it can be annotation or it can be a model output, so you can directly show the images here. And for example, for the second row, you show the same indexes but for the segmentation. So you see like for each axis XYZ the corresponding segmentation, and you see if it is right or not. And this is only one use case, but there are a lot of use cases. But yeah, this is how you can start using Matplotlib for medical imaging, for example. But you can also use it for other tasks, not only for medical imaging. But since the purpose of the course is medical imaging, so we need to give an example on that. And also, if you have any questions about these, you can always leave them in the comment section, or you can leave them in the chat. And yeah, let's continue our course. Here, the things come interesting. I don't know if you already heard about the library called OpenCV, which is especially for computer vision. It is not special for medical imaging, but everything that can be used for computer vision, we can use it in medical imaging. This is the good thing in medical imaging. There are some things that require specific libraries, but there are other operations that we can use with any Python library. For example, this one, which is OpenCV. OpenCV is Open Computer Vision. So it is used for like doing a lot of operations in medical imaging. And between by this operation, we can work with medical imaging. So we can read the files, we can resize them, we can apply thresholding, applying Gaussian noise or different type of noises. We can detect the edge, the contour, a lot of things. Like even you can do image registration, a lot of things that you can do using OpenCV. So for the purpose of the course, I will take like few things that we will talk about here. But of course, like the documentation is always open for everyone. And if you want to, let's say, larger your knowledge in medical imaging using OpenCV, for example, so you can directly see the documentation and see the different operations that can be applied using OpenCV. And then you can like directly use your images or your medical imaging files with the library and see what you can do with it. Okay. So here, if the same thing, if you want to use it, you need to install it, and I have it already. But if you want to install it, you can do pip install open CV, and then you need to add dash Python. Okay, so open CV Python, and then you press enter, it will be installed. I will not install it again, I have it already, but yeah, after doing this, after the installation is completed, you can import it. So to import OpenCV, you cannot do import OpenCV, but you need to do import CV2. So CV2 meaning that you are importing OpenCV. Okay, let's run this. Now it is already imported. To read an image, you can do, let's say, for example, image equal to CV2 dot imread. So it is like the same name, the same function name as we use for matplotlib, but it's not the same function, only the names are the same. Okay, so we have cv2.imread, and here we need to give the path to the image. So we have data slash sample1, for example, and then also we need to specify the type of image. So here it is like a grayscale image, so we have cv2.imread then grayscale, like this. Okay, so now we have read the image. If we want to display it, so we need to do, I will just add it here. So we have cv2.imshow. You can see that like most of the names of the functions are almost the same as matplotlib. I don't know why, but and even if you are using MATLAB, for example, you will see that the same names, imread, imshow, like the same thing that can be used, like the same names that are used in MATLAB, you can find them in OpenCV and Matplotlib. So that will be easier for you to know. For example, if you are familiar with another language or with another library, you can see that whenever you have the same name, meaning it has the same operation. So the same thing here, for example, imshow. Okay, but the thing here, the parameters are different. The same operation, but the parameters are different. So for example, here we need to give the title directly here, otherwise it will not work. So the first argument is the title of the image. So for example, let's say medical image. Okay, and the other thing, which is the image that you need to give, which is what you have read here. Okay, so now we have the image. Now if you run this, you can see that, let me just bring it here. You can see that the image is blank and you cannot visualize it. Okay, and like all your code will be in bug. So you just need to close the code, close the program. Yeah, because there are other things that we need to add while using OpenCV. I just wanted to show you that we can run it, but it will not work. There are some things that we need to add, otherwise it will not work. Okay. By the way, if you are a medical imaging student or practitioner and you are looking for someone to help you to create your deep learning models for medical imaging analysis and desktop applications also, you can always contact us. We do consulting for this for the field, and we can help you build your deep learning models and customized architectures, customized desktop application for your purpose. So don't hesitate to contact us at contacts@pycad.co, and you can also see some of our works at pycad.co/portfolio. So what you need to do here, because whenever you want to display an image, you should add like a waiting key. So whenever you launch the image or launch the visualization, you need to tell the compiler to wait until you give the signal to close the image. Otherwise, the image should be displayed all the time. So to do that, let's just put cv2.wait key. For example, let's say 0. So whenever you press 0, like if you have a window showing the image, if you press 0, like this window will be stopped and the code will be stopped. Otherwise, the code should be always be running. It will be like infinite loop until you press 0. Okay. So I think if we run it, it will not work because we need to restart the kernel, because when we launch the code without this line, like everything was stopped. So we need to restart it again. Now we have restarted the kernel, and also we need to import the OpenCV again because it's not imported. Whenever we restart the kernel, everything is lost. Okay, now let's press here, and here you see, since I have two screens, so the image or the window has been opened in the other screen. But yeah, this is the image that we are having, which is sample 1. As you can see here, this is only one operation to just show the image. Okay, now if we want to do something different, for example, if we want to let's say resize the image. Okay, so just let's add markdown here for resize an image using OpenCV. Okay, now to do that, we will keep the same image that we imported, which is EMG. Now if we want to resize it, we can do resized MEMG, for example, which is like new variable that will store the new resized image. So we have cv2.resize, and now we give the image, which is the one that we want to resize, and here we give the new sizes. So for example, and you need to give the width and the height since it is to the image. So you need to like create new parentheses that will store, because it will be a tuple that will be put here in the same argument. So this argument needs to take a tuple which contains the new x and the new width and new height. Okay, so for example, let's say 500 by 500. These are the new width and height. Okay, and then then everything is there. We can just show the old image and the new image so that we can see the difference. Okay, so here we have cv2.imshow, and here, for example, let's say original image. Okay, this is image, and then cv2.imshow, and here we can see resized image, and here we need to put resized image. Okay, yeah, now we have both images, but also, as you remember, we need to add the wait key, otherwise everything will be stopped. So we have cv2.wait key, and here we put, for example, 0. Okay, let's run it. Now if you want to see, these are the two images. This is the original image and this is the resized image, and you can see that we changed the size. So now here we increased it. So if you want to decrease it, if you want to increase it, so everything is related to you and what you want. And you can see, and this operation is very important. I use it all the time while using medical imaging. So for example, if you are doing training for image segmentation, classification, or object detection, and you want to resize all the images to the same, or to normalize all the sizes of the images, which are the dimensions, to the same dimension. So you need to use a function that does the resize. So you can use OpenCV or any other libraries, but OpenCV is very powerful library that has been used by like a large community. So you can find always answers if you have problems. You can always find like solutions, and there is someone that will help you doing this. So yeah, this is one operation from what you can do. And yeah, let's do other stuff using OpenCV, and you can see that there are a lot of cool things that you can do, and this is only what I will say, but you can find others in the documentation. Now we can do another operation that can be used in image processing and also for medical imaging, which is applying thresholding. So whenever you have an image and you want to take only few parts of the image, or only few pixels or defined pixels from the image, then you can apply thresholding. So you take everything bigger than this value, or everything less than this value, or something like this. So it can be helpful for image segmentation. For example, if you have like very easy type of images that you already know what are the exact pixels for your objects in, or for your organ in the image, then you can directly apply thresholding, saying that if the values are equal to this, or if the values of the pixel are bigger than this or lower than this, then it will be detected, because the output of a thresholding operation will be only a mask with zeros and ones, meaning zeros which are the pixel that has not been detected by the thresholding method, and the ones which are the white pixels, meaning that this part has been selected by the thresholding algorithm. Okay, so we can do that. You can see that you can do it using OpenCV. For example, let's just read another image. For example, EMG equal to cv2 dot imread, imread, and here we can give like data slash sample1, for example, and then we can do the same thing that we did. So cv2 dot imread then grayscale. Okay, so here we are detecting the image. Now let's apply the thresholding. So let's say thresholded EMG, for example, equal to CV2 dot threshold. Okay, when we just call the function threshold, it will apply the threshold. But there are some parameters that we need to specify. So we have the first one, which is the image that we want to apply the thresholding on. Then there are two values. The first value, which is like when we want to apply the threshold, which is what is the minimum value, which when from this value we can apply the threshold. So for example, we have the value, for example, 127, for example. 127 is like minimum value. So all the pixels having 127 or more than that will be detected or will be selected by this algorithm. Then there is the second parameter, which is when we create the mask or when we create the output, what is the maximum value, or what is the value because when we say mask, for example, if like a binary mask, we have two values, which we have the black, which is the 0, which is the background, and then we have the foreground. So the foreground, we can give it any value that we want. So it can be 1, it can be 255, it can be 2, it can be 3, but it will be one unique value that will be applied for all the foreground. So the foreground value here, we can put it, for example, 255, which will be like the whiter value that we can have, which is the 255. Okay, then we have another parameter, which is CV2 dot threshold binary, which is like a binary threshold that we want to apply, which will be 0 and 1. For us here, it will be 0 and 255. Okay, and then we need to select the second value, which is 1 here. First value is 0, second value, which is 1. When you say value, it is not value, but it's channel. So the second channel will have the exact mask that we want, which is 1 here. Okay, now what we can do, we can directly show the images. What we can do, we can copy these so that we can show the original image and the thresholded image. Okay, let's say thresholded image. Okay, so now we are applying the threshold, and we will visualize the image without the threshold, and like what is the threshold, the output of the threshold algorithm after applying it on this image. So let me run this, and you can see, for example, we have this is the output, this is the image that we had, and this is the output. And you can see that we have only 0 and 1, or 0 and 255, which means that these are the pixels that we wanted to apply using the algorithm. So all these pixels that has been detected having the value to 127 or more in this image. Okay, so this is how to apply the threshold. There is another operation, which is detecting the edge in the image. So let me just add another markdown here. For example, let's say threshold using OpenCV. Okay, and here we can do edge. No, I forgot to add this. So we have edge detection using OpenCV. Okay, so now we have the threshold and we have the edge detection. So the difference between threshold and edge detection, so if we have a normal, so let me just rerun this. The threshold is whenever we have a point that or a pixel that has a value very defined, we can directly take it. There is nothing related to a shape in the image or to a form in the image. Like it is being applied to each pixel, and there is no relationship between any two pixels, even if they are neighbors. But there is no relationship between the pixels. So each pixel is passed to the threshold algorithm dependently. But when we talk about edge, so for example, if we want to detect this circle here or only this part, so this we will detect the edge of this form and the edge of this form, the edge of this form, etc., etc., etc. So this is why this is the difference between edge detection and the threshold, the normal threshold. So let me apply it here and show you directly. To do that, I will use another image because this image is very noisy. So let's use this one, which is a little bit clearer so that you can see what we want to do. So yeah, for the edge detection, we need to read the image as well. So we have, for example, MEMG. Let me just copy this so that we don't rewrite again. But here I will put the image 3. Okay, now after doing this, we can define the edge that we want to apply, which is, for example, canny edge. There are multiple types of algorithms that you can use to detect the edges, but the most used one is the canny. So this canny method is for the edge detection. So I will not go through this method and talk about how the math is going there, but I will just show you how you can use Python to do or to detect the edges. But if you want to dig deeper in this, you can always find this in Wikipedia, in Google, or something like this. So here we have cv2.canny, and now we have some parameters that we need to give. There is the first parameter, which is the image, okay, which we have already. The other two parameters, so you need to understand a little bit what I want. Here you see what is defined. Here we have threshold 1 and threshold 2. So the threshold 1 means that any value lower than this threshold, for example, if we can say 1, any value that is lower than the first threshold will be rejected. So it will not be used as an edge. So it will be rejected, meaning that it will be 0 or it will be a background. So for example, I will take 100, okay? Because if I use 1, then we are taking everything as a edge. So we will not see the edge exactly in the image. So I am putting it a little bit bigger so that I can avoid all the values which are lower than 100. And the second value here in this function means that we are taking like any value bigger than this value, which is, for example, let's take it 200. So all the values that are bigger than 200 will be directly accepted as a edge, okay? So you see, anything lower than 100, which is the first threshold, will be rejected. And everything bigger than the second threshold will be accepted. But the other thing, which is when we have values between the first and the second threshold. So here where there is the exact application of the canny edge method. So here there are some equations that needs to be applied. And if you want to dig deeper, you can find this in documentation, not only in OpenCV, but you can directly read in general about the canny edge detector. And you will find what is the answer about these two, because now we cannot talk about everything we see here, but I'm just talking about how you can apply it. And if you get more information about what is the mathematical operations and you see how it is being applied, you will get the relationship between them. Okay, but if you just want to apply the threshold, you can directly use, the edge detector. So you can use this. We have the image, the lower threshold, the upper threshold. Okay, now we have applied the threshold. If we want to show them, we can do the same thing. Let me just copy these here. And here we have the original image. Now we have the edge, for example, image. And here we have edges. I need to delete these. So we have the edges. Okay, now we have the image and the edges. If I run this, you can see that this is the image and this is the edge. So we are detecting all the edge in the image, and you can see here. So if you want to make it more sensitive or less sensitive or something like this, you can always play with these two values. And if you really read the documentation about how canny works, it will be easier for you to play with these two values. So yeah, these are like some operations that we can use when using OpenCV. And like OpenCV, like a very big library that has a lot of operations. We cannot, like, you will find like a course of 10 hours only about OpenCV, and even 10 hours is not enough to cover everything about OpenCV. But here I am just showing you some operations that can be used when, I'm not saying can be used, but I myself used for medical imaging. So if you want to detect edges, you don't need to apply or to find a big library for that. You can directly use OpenCV and it can help you to detect it with a normal, easy, canny detector. And the same thing for other operations. So yeah, thank you for this, and let's see what we have next in the course for the next videos. Now in this section we can start talking about how to use the special libraries. I am calling them special libraries because we like they are special for medical imaging. They cannot be used for something else. When I say they cannot be used in something else, because like most of them reads a special format, for example DICOMs or nifties or something like this, which is special for medical imaging. So if we use them for something different, then it won't be easy to manipulate with them. Okay, so for this reason I will give you some of them that has been used or has been very useful for me in my projects. And you will see that for you, if you are doing medical imaging, these are the most libraries that you will use for your projects. Maybe sometimes you will need another library that can be used for one operation, but most of the operations can be covered by the libraries that I will mention now. Okay, so for example, we will start by PyDICOM. So this PyDICOM library is special for treating DICOM files. It is not the only one, but it is the most used one and the easiest one. Okay, so before using it, as we did for the other libraries, we need to install it. So pip install PyDICOM. Okay, I have it already installed, but if you do want to install it, you can directly press enter, and it will be installed here in your environment. Okay, so now after that you have installed the library, what we can do, we need to import it here. Import PyDICOM. Okay, and now and after that I will import also matplotlib, because I want to use PyDICOM to read an image and use matplotlib to visualize it. Okay, so we have import PyDICOM, and then for example import matplotlib pyplot as plt. Okay, and yeah, before that I want to add a markdown just to specify. We have 3, so here we have PyDICOM. Okay, so now we are talking about PyDICOM. We have these. Let me run the cell so that it will be run and it will be imported. Now what we can do, we need to read the DICOM file. As you can see here, I added another file which is slice.dcm. This is one slice of a whole volume. It is a CT scan, okay, that has been used to segment the liver. You can use it to segment liver, spleen, like lungs. A lot of organs are covered by this type of scans. I will show you one slice of them. So I added it to my folder where I have the images. So yeah, let's start by importing or reading this DICOM file. So we have DCM equal to PyDICOM dot DCM read. So the function DCM read, which is DICOM read, is special to read DICOM file. So you just need to give the path to the file. So we have data slash slice dot DCM. Okay, now we have read the file. If I run it here, if I put DCM, you can see that we have all the information that are like, this is the header. There are more files, so we can see them in the text editor. You can see that there are a lot of files here special for this DICOM file. So most of you maybe will need only few information from this file, but others may need all these files, because all this information, because there are some information that needs to be used to rescale the image. Some of them used to normalize the image, some of them just to center the image. There are a lot of things. For example, we'll use this one. We'll use it for an example. I will show you like when we can use some of these. I cannot cover all the files because it depends to which file, which project you are doing, but I would just take few of them just to show you how you can visualize them, how you can use them as well. If you want to know more about these this information if you want to know more about how, like if you want to go deeply with the DICOM files. I have another course that is special for DICOM, so it is called DICOM Simplified. You can find it in my Udemy profile. So it is special for DICOM, so you can find everything related to DICOM, how to read them, how to treat them, how to convert them, like deeply in DICOM. But this course is not special for DICOM. For this reason, I will take only few examples, but the others I will leave them for like the other time I will leave it for the other libraries and the other file formats. Okay, so here we have DICOM. We read it. Let me just delete this one. Now we read the DICOM file. What we can do, we need to, if we want to visualize the image, then we need to extract the image, because the DICOM file contains a lot of information, not only the image, but it contains the metadata that I was printing or was showing right now. Okay, so to extract the image from the DICOM file, there is, let's say, emg, for example, equal to dcm.pixel array. So this pixel array tag will give you the image array. Okay, so this is the image. It will be in form of numpy array, but it is an image. You can convert it into image. There are multiple ways to do that, but for us, we will not need to convert it. We will visualize it directly. For this reason, we are using matplotlib, because matplotlib can take the vector as it is, like the array as it is, and visualize it. You don't need to convert it into an image and then show it. Okay, so now we have the numpy file. So why I am saying numpy file, because if I do type of image, you will see that it's a numpy file. This is the type of the file that we have extracted from the DCM. Okay, now if I want to visualize something, so just plt.im show, sorry, and here we give the image, which is emg, and then the cmap equal to gray, and then the same thing. For example, we have the title, so plt.title. You see, now we are working with the medical imaging files, which is, for example, DICOM for a CT scan, but we are using matplotlib. For this reason, I wanted to show you like the basics of using matplotlib, basics of using numpy, etc., so that when we use them now for medical imaging purpose, you will see that the same thing that you understood from the basic Python can be used directly in medical imaging. Okay, so even if you have already knowledge of Python programming language, so you have already used matplotlib for other tasks, you can see that you can apply it as well in medical imaging. So let me just complete the code. I don't, sometimes I talk a lot, but yeah, I try to explain everything. So here we have DICOM image. This is the title. And now we have plt.show. The same thing here. I am using it, but in Jupyter Notebook, it is not needed. You can delete it if you want. Okay, so now this is the image. So you can see this is the lungs, and yeah, this is a CT scan, and yeah, this is only one 2D slice that I am showing here. You see that it is very noisy here. You can apply some things to make it look better. So this, we will cover it also in this video. Let's just do something else, then we can go to transforming this image into something cooler to see. Okay, before that, I will show you how you can extract the tags, because you remember when we just did DCM, you see we have a lot of tags. Let's say, for example, you want this specific tag and you need this value for something that I don't know, but you will need this value. So you need to extract it from this metadata information. To do that, I will show you for 2 or 3 tags, but you can do the same thing for the others. So let's say, for example, I want to show the patient ID. So let's put print, and then, for example, let's me do f string, formatted string. So we have patient ID, and then yeah, here I will do this, the brackets, and now here I can directly put the patient ID, but I need to extract it from the DCM. So to extract the tag from the DCM, there are 2 ways of doing it actually. There is the way of calling it from the tag here, like with this reference. Otherwise, you can directly call it from the tag name. So for example, DCM dot patient ID. Okay, so if I print this here, you can see this is the patient ID. We can do the same thing for other information. For example, print F, then for example, study ID or study date, for example. And yeah, study date. And the same thing for example, if I want the modality or patient name. For example, let's do print patient name, patient name, sorry, patient name. Okay, so now if I print these, you can see, because you are seeing like R_004 for the patient name or patient ID, because this file has been anonymized, so they are putting this like it doesn't have any sense, but this is an anonymized file. So yeah, and you can do this as well if you want. So for example, if you don't have the file, if for example your file is not anonymized and you want to anonymize it, this has been covered also in the other course, but I will show you directly. It won't take a lot of time, just to show you one tag, how you can change it, and you can do it for the others if you want. So for example, if I want to change the patient name, so I can directly refer to it. So for example, patient name, okay, and then I give it the new value, for example, pycad. Okay, so I give it the new value. Now I have already changed it. If I print it now, let's say print, or let me just copy it from here, for example, print and patient name. Now we have the new, here it was like R_004, and now it is pycad because we have changed it here. So this is how they are anonymizing the files. You can put anything you want here for any tag that you want. I took only these three, but you can take all of them from the list that you can get when you print the DCM. Okay, so let me delete this, or let me just leave it and go to something else. So for example, now there is something called applying windowing to DICOM image. So this is really interesting. There are multiple ways that you can do this. There are some libraries special for this. For example, you can use MONAI specially to do an operation, to do this windowing operation. This windowing operation is the operation that will let you delete this noise, for example, and make the image clearer, so you can see the organs clearly. So as I said, there are multiple ways. There are some difficult ones and there are some easy ones, but like all of them to take you to the same result. So why would you take the difficult ones, since you can do it with the easiest ones? So let me just show you how you can do it, like just one example of how doing it with the easiest way. And in the future videos, we will use MONAI for some pre-processing operations, and there I will show you how you can do the same thing here, but with a different library, which is MONAI, and you will see that it's complicated than using the same thing that we will use now, which is easier. Okay, so I will show you now the easiest way doing it using NumPy, and in the future videos I will show you how you can do it with MONAI. Okay. Yeah, so, and there is another way of doing it, which I covered in the course. It is easier than the one that I will show you now, but as I said, multiple ways, but all of them takes you to the same result. So, okay, we have already imported the PyDICOM and the matplotlib. We will need also to use the NumPy library. So import NumPy as np, recompile again. Now we have it imported. What we can do, let's read the image again. For example, let me just take it from here. I know that I can directly use the file from here, but I am trying to put everything again so that you can understand like each part dependently instead of using a file from previous cells. Okay, so here let's say applying windowing to the DICOM image. Okay, so here, or images. Okay, so here let me just run it. Now we have the file, we have already read it. What we can do, we can extract the image, the pixel array from the image. And then here, as I said, there are some tags that can be used. So for example, here, what we will do, we will multiply the DICOM array by the rescale slope, and then we add the rescale intercept. So these two tags will help you to do the windowing thing. So you can dig deeper on these, but as I said, this is not the easiest way. There are other easiest ways to do that, but I think this way is the raw way, because if you use another library that will call a function where you give the DICOM file or the link to the DICOM file plus the some values that will be used. So inside the function, they will apply some operations that I will show you directly now. So now I will show you the operation that will be applied inside the simplified functions. Okay. So for example, as I said, here we have the image. It will be dcm.pixel array. Okay, which is the pixel array, which is the image that is inside the DICOM file. And then we multiply it by dcm.rescale slope, and then we add to it the dcm.rescale intercept. Okay, so when we do this, you will see that this will not change anything in the image in reality. Like, let's say visually, it will not change anything. So we need to add something else, which is the most important part here, which is doing a clip to the image. Because if we see the values of this DICOM, this pixel array, like the voxel or the pixel values, in reality, we should say voxel because we are working on 3D. So the 3D version of pixel called voxel because it is 3D. It has width, height, and depth, not only width and height. Okay. So here we have the voxel array. If we see the values in the DICOM files, we'll see that the values are between, let's say, minus 3000 to plus 3000, sometimes minus 1000 to plus 1000. So there are some illogical values. So since these values are, let's say, minus 3000, it is very, very small value, and we have plus 3000, very big value. So these changes may create these type of blurs or this type of let's say noise. Okay, so what we can do, we can decrease this range. So instead of having an image that goes from minus 3000 to plus 3000, we can have an image that goes from, for example, minus 200 to plus 200. So if you can play with this operation, you can find a best visualization experience. Maybe the values cannot be the same for all the type of data, but from my experiments, I found that like most of the files or most of the cases prefer having the values minus 200 to plus 200. So the minimum voxel value that can be used or that can be let's say present in the DICOM file or the pixel array, like the minimum value can be minus 200 and the maximum value should not exceed the 200. So using this range, so like instead of having the big range, we are smalling or we are decreasing the range. So using these values could give best results or best visualization experience. But as I said, maybe sometimes it cannot work. For this reason, you need to play with these values to get the best experience for your type of data. Okay, so we have image equal to np.clip. And here we need to give the image, and then here we need to give the new values, as I said. So the minimum, as I said, I found that minus 200 is the best, and the maximum is plus 200. So yeah, now we are done with windowing the image. If we visualize this, you will see that it will be clearer than the one above. So to do the visualization, we'll do the same thing. Let me just copy it from here. Be easier than writing it, and here we need to put image. Okay, now let me show you. So as you can see, now the image is clearer than the first one. As you can see, we had this white white noise. We have here the inside, and you can see everything is clean now, and we can see the organs, we can see everything, you see. So yeah, this is how to apply the to apply the windowing to DICOM file. Let me just add another operation. For example, if you want to save your DICOM file in, let's say, DICOM image, so the pixel array, you want to save it as a NumPy file. Maybe you will need it for something that I don't know, maybe for a training or for something else. So what you can do, you can directly take the image, which is the pixel array. So for example, image, which we have already, you can save it as NumPy array. To save it as NumPy array, what you need to do, np dot then save. And here you need to give the path to the image. So for example, let's say data slash, then for example, np dcm file. And also you need to give the extension, which is npy for numpy. And then the second argument will be the image itself, so which is image. Okay, so if I run it now, you can see that I created a new file here, np.dcm file.npy. So you can use it for anything you want, for training or for anything, for medical imaging, because I saw that a lot of people use npy files for training image segmentation models for deep learning. So I'm talking about deep learning. So if someone is training a deep learning model for image segmentation or something, I saw that some people use the npy format. So this is how you can create it if you want. As well, you can convert these files, DICOM files, into JPEG, PNG files. Yeah, and all these things have been covered in the other course. So if you are interested, especially for DICOMs, you can see the other course for more information about this. So this was for PyDICOM. You can see that these are the basic operations that you can do. I don't think that you will need something else from this library, but maybe you can dig deeper for other information. But most of the time, my project, this is all what I needed. But yeah, documentation is always present. So yeah, let's complete our course for other libraries. Now let's talk about another library called Nibabel. So this library is also interesting to work with Nifty files. So for the DICOMs, we saw how to use PyDICOM. Now we will see Nibabel for Nifty files. Okay, and as I said, always there are multiple libraries for each format, but these are the most basic ones which are used everywhere. So PyDICOM for DICOMs, Nibabel for Nifty files. Even if you see like some advanced libraries, for example MONAI, you will see that at the backend they are using Nibabel to read the Nifty files. You will not see that in the front end. So when you use your MONAI code to read the Nifty files, you will not see the Nibabel somewhere in your front end, but in the backend they are using Nibabel. The same thing for PyDICOM and the other basic libraries. Okay, so here you see that I added a new file to my data directory called patients.nii.gz. This is a Nifty file. So the Nifty files can be .nii or .nii.gz. So when we have the .gz at the end of the file, meaning that this is a compressed Nifty file. Okay, so this is a compressed Nifty file, so nii.gz. Now let's start doing the coding part. The first thing as well that you need to do is to install the Nibabel. So you do pip install Nibabel. Okay, for me also I will not install it again, but just press enter and it will be installed. Okay, now what we have to do is that we will import the Nibabel library. So import Nibabel as an IB, so just to have a shortcut instead of putting the whole Nibabel each time. So we are shortcutting it by lib nib. Okay, the second thing that we need to import is matplotlib. So we will use the matplotlib to show one slice of the image of the Nifty file. Okay, so we have import matplotlib.byplot as plt. Okay, let me run this part here. Okay, now what we can do, we need to read the Nifty file. So before doing anything with the file, we need to read it first, which is loading it. So here, let me call it, for example, an II, which is Nifty file, for example. This is the name of the variable. So we have nib.load, and then we give the path to the file, which is data/patients.nii.gz. Now we are loading the file, but we are doing nothing with it. Then if we want to visualize one slice, you remember at when we were talking about the matplotlib, when we spoke only about matplotlib, we said that even if we have a 3D array, which is the case here, it is a scan, CT scan. When we have a 3D array and we want to visualize only one slice, then you remember we said that we need to take like everything in the X, everything in the Y, but for the Z, we specify which slice. So for example, 0, 1, 2, 3, etc., etc. This is when we want to show the axial axis. But if you want to show another one, so you can play with the X and with the Y. Let me show you here how we can visualize an axial slice. So to do that, we'll create a plt.imshow, the same thing that we did before. So imshow here, and then we give the array. But as you remember, this plt will take it to the image. Then what we need to do, we need to extract the image first, and then we show it here. I can do everything in one line, but just for the explanation purpose, I will split everything here just to understand what are the steps that are being happened. So we have NII, then array equal to, we need to extract the array from the image. So before, when we were using DICOMs, we had the pixel array, which was extracting the array or the image array from the DICOM file. Here we have the F data, frame data. This is what the variable or the tag that contains the 3D image array or 3D array that we have for this patient. So to do that, let's have NII, which is the nifty file that we loaded, that get F data. F data, as we said, it is frame data. So we have the frame, which is the image. So we are getting or returning the frame data here. Now this array here, this NII array, contains the 3D array. Okay, what we can do now when we want to visualize only one slice, we need, especially when I said I want to visualize the axial slice, I have to extract the one slice from the whole array. To do that, it is very easy. So we have NII array. Then, as we said, you remember we said we take all the X, all the Y, and the Z, which is the axial. We can take 0 or 1 or 2, depending to which slice you want to display. Okay, so here we are playing with the slices, or whenever we change here, we are going to the next slice. So now we are taking the first slice, which is slice 0. Then we need to specify the CMAP equal to gray. Okay, now everything is set. We need to show the title, for example, plt.title, and then here we have nifty slice, for example. Okay, and we can add this plt.imshow, just that it will be you will always use it, because as I said, if you don't use Jupyter Notebook, you cannot visualize the image without this. Okay, so I am just adding it so that you will recognize it all the time. Now let me run the code. As you can see, here is the first slice, which is slice 0. If I want to print the slice, let's say 20, so let me just do this, and here this slice 20, etc., etc. So now whenever we are playing with this value, we are changing the index, which is the slice that we want to display. So this is only to do visualization. Let me just add a markdown here. Markdown visualization using Nibabel. Okay, now let's do something else. You remember when we worked with DICOMs, we were extracting the metadata from the DICOM file. So we had different tags. So for example, patient ID, patient, let's say study ID, study date, and all the metadata that we had. We can do the same thing with Nifty files, but the thing here, we don't have the same, let's say, we don't have the same metadata. So for example, in the Nifty file, or the header of the Nifty file, you cannot find the patient name or something like this. There are other metadata that can be used to pre-process your files, for example, but there is no, the file, let's say the information are not the same, or the type of tags are not the same for Nifty and DICOM. I will show you the different tags that we have here so that you understand. So to show the Nifty tags, we need to print the tags, the header, sorry. So, sorry, I think, yeah, this is a markdown. extracting the tags from the metadata, for example. Okay, now we have the print, and then we have the header. So we have the NII, which is the Nifty file that we loaded. We don't use the NII array because NII array is only an array, so it is a NumPy array. It doesn't contain any metadata, but the metadata is in the whole Nifty file that we loaded, which is NII, the name of the variable. Now if we do that header, you may say why we are using print since we are already using Jupyter Notebook. But yeah, if you just put NII.header, let me show you, it will not print it. It will just show you this, which is the location of the header, but it is just telling you that is a header from a Nibabel library, but it is not showing you what we have inside the header. So you need to add the print so that you can see everything. So these are the different tags or the different metadata that you have in this file. Like the file is bigger than this. Let me just reload this. We can see in the text editor that there are other files that are not being showed there, but yeah, if you need any file from these, you can directly extract it from here. But for now, I don't think that it will be important. I will show you how you can like extract only one file or one information, but you can do the same thing for the others if you want. So to extract, for example, let me extract the shape, for example, of the file or of the image. So there are two ways of doing it. You can directly take it from the NII array, or you can take it from the header directly. So you can do print. Let me add multiple prints. So for example, let me do formatted string. So we have data shape, okay, and then we have the shape, which is NII dot shape, okay. So this is to print the shape. Let's do the same thing for something else. For example, if we want to print the pixel, or in reality we should call it the voxel dimensions or the voxel size from the header. So we can do it like this, formatted string, and then we do voxel size, and then we have the header. So NII dot header, but here we cannot just do as we were doing with DICOMs. We directly do, before that we were doing DCM that header, or that pixel dim or something like this. We can directly give the name of the tag in the calling part. So directly NII dot patient ID or patient name or something like this. But we cannot do the same thing here because it is different and the library is different. So we need to extract it from the header. So we do NII dot header, and the header will be kind of the direction, a dictionary. So we need to give the key. For example, here we have pixdim. So pixdim is the key for extracting the pixel dimensions from the header. Maybe I missed something here, but yeah, maybe because I'm using first only one here. Now we shouldn't have problem. Yeah, so now we have the pixdim. So we are printing the pixel dimensions or the voxel dimensions from the header, and we can do something else. For example, if I want to have or to note the type of data that we have, which is the type of the NumPy array that we visualized here, we can do it just by print and formatted string, for example, and let's put data type. And then here, since we are working with we want to show or to visualize the data type of the NumPy array, then we need to extract the D type from the NumPy array. So there are two ways. like doing NII dot get f data dot d type, or since we have already the NII array that we have already extracted, we can directly do the nifty or the NII array dot d type. Okay, when doing this we can directly sorry, it is not a function. When doing this we can directly see the type of the array that we have, or the type of the data that we have in this array. Let me put this, and now you can see this is the dimensions or the shape of the whole volume, which is 512 by 512 by 68 slices. So we have 68 slices. We can go here until 67. Let me just show you 67. If I put 68, it should be an error, because we have 68 slices that start from 0 to 67. So if you do 68, it means that there is no slice with the index 68. This is the last one, which is 67. Okay, the next thing is the dimensions. The most important part is this one. So you have the width, the height, and the depth of each pixel, which is a voxel. 3D pixel is a voxel. So we have the width, the height, and the depth, which is 5 millimeters. Okay, so this is how we can extract the data from a Nifty file. I will just add another thing that may be helpful for you. It was helpful for me, so I am just selecting the things that was helpful for my project. So if you want to know more about these, you can always check the documentation. So let me apply some transformations or transformation matrix to the Nifty file. Let me complete this transformation to the Nifty file. Okay, now I will explain. For example, when you have, I added this, maybe we don't need it. Okay, why I am showing you this, because for example, let's say you are doing image segmentation and you have the final mask, which will be a NumPy array or a TensorFlow, a torch tensor. And in this case, you don't have any metadata, you don't have any affine matrix, you don't have anything with you. So if you want to just save this file, you cannot use it, or you cannot overlay it on your volume or on your input, which is CT scan, for example, here, because the affine matrix of the scan or the input scan and the affine matrix of the segmentation file are not the same. For this reason, you cannot do directly take the file or the array as it is. You need to add some things, and the most important thing is this affine data. The affine matrix. Sorry, I will show you how you can just edit it here, because we don't have the both files. We don't have the scan and the segmentation. We have only the scan. But I will show you how you can edit it in the scan, and like this, it will be easier for you to apply it whenever you have the segmentation. Okay, so let's say, for example, you have a Nifty file that you have read, which is NII, but let me rewrite it again so that it will be clear here. We don't work with, where is it? And yeah, this one. Let me just rewrite it again here. Okay, now we have the NII file. What I will do, I will create the affine matrix. So this affine matrix will control the directions and the positions of the segmentation and the volume. So if you apply or if you multiply the volume, because the volume or the scan that you have is already multiplied by a matrix. Okay, that will create like the relationship between the real world and the real world coordinates and like your coding coordinates. So if you have the scan is already multiplied by a specific affine matrix, and you have the segmentation that hasn't been multiplied by this affine matrix, so you will have like two 3D arrays in different spaces, which cannot be at the same space or the same place. Never, you will never have this. So you need to multiply both of them by the same affine matrix, so that you will have the same real world coordinates for the volume or for the scan and for the segmentation. Now I will show you the like a random one, which has been used all the time. So whenever you don't know the real world coordinates applied in the volume, which is easy to extract, it is not a big deal. You can find this in the documentation, but it is not a big deal. Maybe we can cover this in the next the next courses, because it's not our subject here. But yeah, you can, if you cannot extract or you cannot find the affine matrix that will take you to the real world coordinate, most of the people applies the I matrix. The I matrix, so which is, for example, you have, let me just copy it and paste it so that will be easier instead of writing it. So it will be something like this. You will have the number, for example, this is an I of 4. So you have 4 by 4 matrix, which has the I, which have the number 1 here. Okay, so you have the first value 1, and then the second value, the third value, and the fourth value. So this is the I matrix that has the value 1. Okay, so this is the most normalized or the most used matrix whenever you don't have the exact coordinates of the real world affine matrix. So when you don't have these, you can apply this, but this is a temporary solution. It cannot work all the time. So preferably you should see how to extract the real affine matrix from your scans, and you apply it to the segmentation. So as I said, this is not a big deal, but since it is not the purpose of this course, I am not going to cover it, but maybe in the future courses. Okay. Now, after having the affine matrix here, what you can do, you can apply it. So there are two ways of applying it. For now, since we have already the Nifty file, we want just to apply the affine matrix. You can do nii.f.set. So because when we want to get something, we are doing get. Now we are setting something, so we are set, then q form. Okay, so set q form, and then you give the affine, which is this one. So this is the way of applying the affine matrix when you have already the Nifty file and you want to change the affine matrix to something, so you give it like this. But if you don't already have a Nifty file, you have just a NumPy array and you have the affine matrix. That can be this one, normalized one, or you have the real one that you have extracted from the CT scan. So in this case, you cannot apply it using this because you don't have already a Nifty file. So you will create a Nifty file. This also can be found in documentation. It is very easy to create a Nifty file. Just one line, creating Nifty file using Nibabel, and you give the array at the first argument and then the affine matrix in the second argument, and it will create directly a new Nifty file with the exact or with the correct affine matrix. But here, since we have it already, we are just applying it. After applying it, you can save it. You can save the new file. So for example, we have nib.save, and here you give the matrix, or you give the new Nifty file that you have, which is, for us, it is always the nii, because we didn't create a new one, we just updated the old one. So we have nii, and here you give the path to where you want to, for example, patient, but let's say transformed. Okay, so for example, we have the we are saving the new Nifty file to this folder here. Let me run it here. You will see that it will be saved here. Okay, so this is how you can save the new file. And the same thing, if you didn't use this one and you created the new file, which with the new array and the affine matrix, the same way you can use to save. So you just need to replace this here by your Nifty file and the path, and it will be saved. Yeah, so I think we came to the end of the video. This is about Nibabel. So you see these different things that we can do using Nibabel. And also there are always other things that we can apply. This is a simplified version. But just to start your coding part using Python for medical imaging. And if you want like deeper things in a specific library, you can always check the documentation. See you in next video. Now I will put a quick video about converting DICOM to Nifty. I think most of you may need this kind of conversion because I use it all the time. So for example, if you have a data set shared with you in the DICOM format and you need to convert them into 3D files, which are Nifty files, you can do that easily with a library called DICOM to Nifty. To install it, you can just come here and put DICOM to, pip install DICOM to Nifty. Okay, and when you press enter, the library will be installed and you can use it for your conversions. I will just show you. I don't have a let's say an example to show you here. I don't have files to show you. I have some files, but I cannot share for now. But I will just show you the exact code that do that. So you need to import the library, which is dicom to nifty, and then there is the where you need to define the path. For example, you have path to dicoms. So path to dicoms should have it should be a directory containing all the dicom files that you have for the same patient. So you take these dicoms and you convert them into one nifty file. So for example, let's say path to dicoms. Okay, so this is the path or the input path that you will need for your function. So yeah, now we have only one line to do that. So we have dicom to nifty dot. There are multiple functions to do that, as you can see here, but the most used one, which is dicom series to nifty. So this function dicom series to nifty will convert a dicom which is directory or dicom series, one directory containing all the dicom series for us, which is path to dicoms, sorry, and here you put the path to the output. You need to put the path plus the name plus the extension. So let's say, for example, data slash then the name of the patient. So we have new, or let's say nifty patient, for example. I need to add the extension, so it can be NII, which is a normal dicom, it's normal nifty file, or you can add the .gz for the compressed file. So whenever you give the extension, if you give the .gz, like the code will directly compress the file and give it to you. Preferably I use all the time the .gz because like the size of the file is way smaller than .nii. And since you have a lot of cases, if you just leave them, all of them .nii, like your disk will be full and you cannot save your file. So preferably you need to use nii.gz, because whenever you use Python scripts, any Python library that uses nifty can read the nii and can read the nii.gz. So you won't have a problem with the extension .gz at the end. So why won't you use this and have more space for more cases? I hope that you took this, but yes, you can give nii or nii.gz and you run the code here and everything will be there, and you will convert the dicom directory to one nifty file. And if you have multiple directories, let's say multiple directories, you can create a for loop that passes by all the dicom directories and convert each one into nifty file. So yeah, you can use glob, for example, to find the directories, and then you use use this line here in the for loop to convert each directory to one nifty file. Yeah, and this was for the dicom to nifty. Let's see for the other libraries. Now let's talk about another library called simple ITK. It is the simplified version of the ITK library, which is a very large library, like from Kitware, the same as VTK and the other libraries. So here I will show you just few examples of using simple ITK, but you should consider that you can do anything in medical imaging using simple ITK. Like simple ITK or ITK, like both of them are very, very large libraries. It's not made only for, let's say, only for converting files or only for loading files. Like it is for everything. So you remember when we spoke about OpenCV, which is a large library for computer vision. So it is for any image processing types. But of course, OpenCV is very limited in medical imaging because it cannot read the different formats and treat these formats, convert these formats. But simple ITK and ITK, VTK, these kinds of libraries can do anything with the file. So it can read any type of medical imaging formats. It can read DICOMs, NIFTs, NRRDs, STL. Like it can read any type of data, convert between these types of data, do morphological operations, applying noises, like doing smoothing. You can do anything. Yeah, so yeah, I will take only a few examples just to show you how you can start with these libraries. But of course, if you want specific thing, you need to dig deeper on these and find your solution. Okay, so let me just start by importing, or before importing, you need to install this library. So you need to go to the terminal and you put pip install, then simple ITK. You need to write it like this. So just by putting or pressing enter, you should install this, but I will not install it again. But yeah, this is how you can install it. Now what we need to do is to import this library. So import simple itk as sitk, just to make it easier. So shortcut of simple itk is sitk. Then I will import the matplotlib.pyplot as plt, just to do visualization. And you can see here we are using matplotlib everywhere, even if it is not special for medical imaging. But yeah, let me delete this markdown. Okay, now I will create a new one here. I don't know what is this. Yeah, okay, now we imported the simple itk and we imported the plt. What we can do is to read, for example, a DICOM file. You can read DICOM files, you can read nifty files, you can read anything you want. So let's read the DICOM file. So we have dcm equal to simple itk dot read image. Okay, read image, and we give the path to the file. So data slash slice dot dcm. Okay, so not that but slash. Okay, yeah, okay, we have here the file that we want to read. The second thing that we need to do is to extract the array image or the array from the DICOM file. Remember when we were using PyDICOM, we had the pixel array, which is the tag that will extract the image. Here in simple itk, it's called get array from image. So to do that, let's say image equal to sitk dot get array from image, and then we give the file. So here when they are saying image, they are talking about the DCM file. Okay, so they are getting the array from the image, which is from the DCM file. Now they have the array. Now we can directly plot it, or we can visualize it or show it using plt. So we have plt dot imshow, I don't know what I'm writing. So here we have image, okay, and then we have the cmap equal to gray, okay, and then we just put the plt dot title, and then we give the title, for example, DICOM image, and then we do plt dot show. Okay, now let's see what we have. There is an error here. Yeah, because we should put us or assign to the first element, because when we are extracting this, it has multiple elements. So the first element is the array that we want. So if we do this, we can see the first element, because you see we are not working with the nifty files. It's one DICOM file, but this function return other things than the array that we want. So for this reason, we take the first element, which is the array, and we can visualize it as we are doing here. Okay, so this is the image that we are visualizing. Now what we can do as well, for example, we can extract the data. So we can add the markdown here, visualizing the DICOM file, I think, file using simple itk. Okay, now what we can do, we can, for example, do the extracting the metadata. So extracting the metadata from the DICOM using simple itk. Okay, now we have the extraction of the metadata. What we can do, there are multiple ways, but there is a function called get metadata. So this get metadata, it can directly take the tags. You remember when we were working with the DICOMs, we had the tags, for example, 0, for example, let me just show you here, just to be easier for you. Let me run this, and I will add a code. So for example, print, and we have the DCM. You remember here we have the keywords and we have the tags, which are these, and after that these are the values. So to print these values, you can either use this, which are the words or the keywords, or you can use the tags which are these, because you need to know that each keyword has different tag. So when using simple ITK, we can use directly the tags. So when we use the get metadata, we give the tag to that type of data that we want to extract, and it will return it. For example, if we want to return the patient ID, so we have print, and then here we have formatted string, and we have patient ID, and then we have the brackets, and here what we can give the DCM, which we had before, that get metadata, and then here we give the tag. So the tag for the patient ID is 0010, then the slash like this, and then 0020. So this is sorry, I made the same error. I need to put it like this. Okay, now when doing this is the tag for the patient ID. So if I print this, sorry, maybe I missed something, doesn't have the file. Yeah, I am, because the thing here, when we run this cell here, DCM now is like the name of the variable DCM is taken by the library pycad, which doesn't have the function there. So we need to rerun the cell here when we have the new DCM, and now it should work, because that, like, we have the same variable, we gave it to two different libraries. But now, yeah, DCM it is working because we are assigning it to simple ITK and not pycad. Now we can see the patient ID. We can do the same thing for the study ID, for example, which is, let me rewrite it here. We have 0008, and then we have 020. It is the same thing. So now we have this study ID. It should be study ID. And we can do the same thing for the others, like for the other tags that we have already in the DICOM file. But yeah, this is only one example. And yeah, as I said, there are multiple things that we can do. We can also convert the array that we extracted here into a NumPy array. We can convert it into PNG, JPEG, and this kind of files. We can do a lot of things with these. But yeah, I will just stop here. And if you have a specific question, you can leave it in the discussion. Or if you want to know, like, if you just want to understand more things about these libraries, you can check the documentation. But as I said, if there is specific thing that we didn't talk about here, but it is specified with this kind of operations that we discovered in this course, you can always leave them in the discussion, or you can send me direct message, and I will see how to help you with this. So let's continue our course. Now let's talk about another library that can be used for medical imaging, which is NumPy STL. So this NumPy STL library is not special for medical imaging, but it can be used. So for example, when you see NumPy STL, meaning that it is like he's using the STL files. So maybe not all the use cases in medical imaging may need the STL format, but from my experience, a lot of tasks, especially when we come to dentistry or something like 3D printing the organs or something like this, most of the time you will need the STL files, because when you want to print 3D print something, preferably like something, let's say something is an object, so preferably you should use the STL format. You can use other formats, but like STL is the most used one. So let's say you have a nifty file that you want to convert into STL. When we say nifty file, meaning that the segmentation, for example, you have a CT scan and you are segmenting, annotating, let's say the liver, the lungs, or maybe you are segmenting the brain tumor part, or the brain plus the brain tumor, and something like this, and you want to 3D print them. You want to convert them to STL, and then from there you take them and print them, for example. Okay, so to do that, you can use the library called NumPy STL. So this NumPy STL allows you to do this, but in reality it works with the NumPy array, not with the Nifty directly. For this reason, we need to adapt the code so that it can work with the Nifties. So I will give you an example to do that. So this NumPy STL can do other things, but the most interesting thing is the one that I will show you, which is converting Nifty to STL. If you want to dig deeper, also, of course, there is the documentation for that. Okay, so let's start by defining the importing the library that we will need. So as I said, the NumPy STL does not treat the Nifty files, so we will need another library that treats this. So we will import the Nibabel, the most used and basic one. So Nibabel will help us to treat or to load the Nifty files. We will need the NP or the NumPy library. Maybe not for the moment, but let me just import it. So import NumPy as NP, okay. And then also we need to import the NumPy STL. Sorry, I did not show you how to install it. So when you want to install it, you just need to press like pip install NumPy, then dash STL, and press enter. It will be installed. But the thing here, when you want to use it in your code, you cannot do import NumPy, for example, STL. This doesn't work. When you want to import it, you just put import STL. So, but for us, we will import another thing. So from STL, import mesh. This STL here means that we are working with NumPy STL. You need to very be careful, because there is another library called STL. So if you do pip install STL, you will import another library and you will install another library called STL, and you can import it here, but it will not work for your project because it doesn't have like the same functions or the same functionalities. So you need to be careful with this. You need to install NumPy STL and you import STL. And remember, if you do it wrong and you install the STL, you need to delete the environment and create new environments. Because the thing, what happens, you will have, when you do import STL or from STL import mesh, for example, it will find two things. It will find the STL that you installed, and it will find the NumPy STL, and both of them needs to be called by STL. So if you do this, you will have a confusion and nothing will work. So you need to clear your environment and reinstall again the NumPy STL. Okay, now let me just run this to import the libraries. What we can do, we can define, for example, the path to the segmentation file. So for example, we have file path equal to, I added a new file here in my directory called Brat S20 training. So this is a very popular database for the brain tumor segmentation. So I took only one file. So it is one segmentation file for a patient that was in the database. So let's say data slash this one, Brat20 training 001. So this is only one file from that. If you want the whole database, you can find it in Kaggle. It is always available there. But yes, I downloaded only one file just for the course. But okay, let's see how it works. The first thing that we need to do is to extract the array or the NumPy array from the DICOM, from the Nifty, sorry, because the NumPy STL function or library, it takes as an input a NumPy array and the output will be STL. So it doesn't take Nifty as an input. For this reason, we need to have the other stage that extracts the NumPy from the Nifty. To do that, let's just put, for example, Nifty file equal to nib.load, and here we give the file path. Okay, now we have the Nifty file. We need to extract the NumPy array equal to Nifty file dot, remember we did get f data. So now you see how I am using the same basic things that we saw before. We saw this, like loading the Nifty, extracting the array. We saw how doing it just like simply uploading a Nifty file. But now we are using this Nifty file for something else. So for now we are, for example, converting it into STLs. So now it comes the part that uses the how do we call it? Use the STL file. But before that, I forget to import something else, which is the measure. So from SK image. So this SK image is a scikit image. If you want to install it, just put scikit image, pip install scikit image, and it will be installed. It is also for image processing parts, not special for medical imaging, but we can use it here as well. It is being used for the like 3D point clouds, for 3D images, for cubes, meshes, all these things. You can use this kind of libraries. I don't use it all the time. Maybe this is the only way or the only time that I am using it when converting from Nifty to STL, but because there are other simpler libraries that can be used for the same functionalities. But yeah, if you want to learn more, you can always check the documentation for this. So we import measure. Okay, let me recheck again. Now it is imported. What we can do now, we need to define the verts, faces, normals, and values. So we have verts, faces, normals, and values equal to measure dot marching cubes, and here we give the NP array, the NP array that we extracted, and we compare it with 0. Okay, everything is higher to 0, like bigger than 0, we take it. Okay, now what we can do after doing this, we create the object 3D. So obj 3D, we cannot put 3D object because we cannot start with a number. So we have obj 3D equal to mesh that we imported from STL dot mesh, okay, with the uppercase. Then here we have np dot zeros, and then we give the faces dot shape of 0. Okay, maybe you will not need to understand all this stuff if you are just trying to convert a numpy to a Nifty to STL. So you just need to apply these functions. No need to understand everything, but if you want, always there is documentation for this, because I cannot dig deeper in each line of code, each functionalities. Otherwise, the course will be like about 2 days. You see. So here we have the data type equal to mesh dot d type. Okay. Now we completed this part. What we can do now, we need to have like for ef in enumerate face. So like the I which we have at the beginning is the index, and F for the faces. So for face in faces in reality, but in enumerate we'll have like we are like passing by the faces, and for each face we have an index. So starting from 0. So the face 1 will have the I equal to 0. Face 2, I remember you see like this is for loop, normal for loop. But yeah, just I wanted to talk about this. Now we have obj 3D. Then dot vectors. Okay, then vectors of I think I didn't write it well. So we have vectors of I equal to verts, okay, of F. Okay, now what we need to do after doing this, the file is already created. We need to save it so that we can visualize it somewhere else. So we have obj 3D dot save, and we need to give the path and the file name plus the extension. So we have data, for example, slash output brat, then let's put the extension .stl. Okay, I will run this line of code. You see that the file has been created. What is it? The output. Now why I cannot see, maybe, yeah, sorry, it is here. So we have output.stl. Okay, now if we want to visualize it, we can use, for example, 3D slicer, or we can directly visualize it using the 3D viewer of Windows. But let me use slicer. Okay, we have slicer. Okay, now let me search for the file. Output Bratz STL. Okay, now I am opening it. Okay, yeah. So this is our file. So this is the file that we converted. It was a Nifty file. You see that it needs some smoothing. So we can apply smoothing either on a Nifty file or on the STL after conversion. But yeah, after smoothing, it will look clear. But yeah, this is how to convert it into STL. And you saw that the code here, it doesn't take the Nifty as input. Like this part here, this is the interesting part. It doesn't take a Nifty as input. It takes a NumPy array, but for this reason, we needed to use the Niba bell to extract the NumPy array from the Nifty file, and then everything is the same here. Okay, so I hope that this was helpful. Let's see about the other videos. So to talk about the last library here for the list that I selected, like here, these libraries are special for just, let's say, visualizing, converting images. So there is another one, which is ITK. Remember before that we talked about simple ITK, which was like special for doing reading DICOMs, reading Nifty, reading NRRD, doing a lot of things. But it is a simplified version of ITK. So now there is the ITK, which is the official version of ITK, because the other one is simple ITK. So it is a library from Kitware. So this library here, it contains a lot of operations as well. But I will take only 2 operations to show you. The first one is always the visualization. If you want to visualize an image using ITK, and the second operation that I will show you, which is like applying the smoothing. So if you have a let's say an image or 3D image Nifty file that has been outputted from a deep learning model, and you will find a lot of noise in the image, and you want to apply some smoothing to get like smoother value or smoother looking when doing visualization, you can apply a smoothing algorithm using the ITK. So I will show you these 2 examples. The first one will be visualization. Second one is the smoothing. Okay, so the first thing that you need to do is to install ITK. You can go directly to your terminal and then pip install ITK. Okay, after installing ITK, you can start doing your project. The first thing that we need to do is to import the ITK. So import ITK. And we need to import the matplotlib as well to do the visualization. So import matplotlib.pyplot, pyplot as plt. Okay, let's run the cell. Now it is there. What we can do, we need to read the file. So for example, we have image equal to itk.imread, and then we give the path to the file. So for example, let me take this path here and put it here. Now we read the file. What we can do now to do the visualization, we need to extract the array from the image. So to do that, there is a function. So let's create an array. For example, the function called like itk.arrayView from image. So arrayView from image. So this is the function that will get the array from the image here. Okay, now we have the image. What we can do, we need to use the pyplotlib to do the matplotlib, sorry, to do the visualization. What we can do, we can create an image. So imshow. Okay, and here we give the array, which is here array. But the difference here, when we were using the other libraries, when we want to visualize the first slice, we should say always everything, comma, everything, comma, then we give the index. But here you need just to give the index of the axial slice. So you just need to give 0, for example. So 0 will return all the axial slices. Like you don't need to specify like all X and all Y. You just need to give the first index, which is 0. So it will return the axial slice directly. You don't need to specify the X and Y axis. So then we have the CMap equal to gray. And then the other thing, which is plt.title. And then here we put the, for example, Nifty slice. Okay. And then we add the plt.show in case. Show like this. Okay. So now this is the first slice, but I think since we are taking a segmentation, so the slice is empty. Maybe we can try with the other case. For example, let me take the patient. That's NII dot GZ. Okay. Okay, now we have the slice that's because the other slice was an empty slice because it was segmentation. So the first slice was empty by default for that specific patient. But now we have the scan, which has already something that we can visualize. So this is how you can do visualization. Now let me show you how you can do the smoothing using also ITK. So to do that, the first thing we need to do is to read the image, but since it is already read, we will not redo that again. To create the smoothed image, it can be done using only one line of code. You can see like this. So we have a smoothed image. Okay, we can call a function from the ITK called median image filter. So we will apply a median image filter. So applying the median to the image with a specific radius will create a smoothed image. So there are two arguments that we need to give. The first one is the image, which is what we had before. The second one is the radius. The radius here for this case, like more you increase the value of the radius, more the image will be smoothed, and also the algorithm will be slow to complete that. So for example, let me apply 8 for the radius. But now after completing this, we have applied the smoothing, but we didn't save the image. So to save the image, you can use the function ITK that's right. Okay. And then imWrite, sorry, not right, imWrite. And then here the first argument will be the image, which is smoothed image. And then the second thing is the path. So for example, let's say data slash smoothed image dot NII dot GZ, for example. And when you run the cell here, a new file will be created. It may take a few seconds since it depends to the radius. So since we are taking the radius equal to 8, so it may take about 10 seconds to complete this operation. So let me show you directly what it gave me after doing this, after using this algorithm. So this was the input image, and this is the output. So this is after smoothing, after applying the value the value 9 for the radius. So you can play with this, and you can find that maybe sometimes you can apply only the value 5 or 4. It can give you good results, and this process will be faster than applying 9. But you can experiment this with your data. But yeah, as you can see here, this is the segmentation or the annotation. It is not. It can be also your output, like the output from the model. You can see that it's very noisy, not clear, and something like this. But here, like very, very clear, that you can use, you can show, you can visualize, you can do anything you want. Yeah, so these was the two operations that can be useful with ITK, and also there are other operations that you can find in documentation, but this is just starting. So yeah, see you in next videos. Now we can start working with some advanced things, which are using MONAI for some pre-processing operations. In reality, in the backend of MONAI, they are using almost the same libraries that we used, or maybe they are using the same method that the other libraries used, but they are just adapting them and making them easier to use. So instead of creating the whole function that will crop an image, that will rotate an image or something like this, you just need to call a function from MONAI and it will do the job for you. So before that, you need to install MONAI. So to install MONAI, you need to install it using pip. So pip install MONAI, okay. And after installing it, we can start working here in this in this section. So this section will be only about how to do pre-process using MONAI. So this will be our important section, because the others were only basic Python scripts. But here we will really show how we can use the different things or the different basics that we understood for real world operations. Okay, so yeah, before starting I just created these helpers that it will be easier for us to work instead of repeating everything. So now we are here we are just importing the ones that will be repeated, so nibabel, matplotlib and numpy. We will see when we will use them after, for not for now, but yeah. The other thing, I created two functions. The first one is show slice 3D, sorry. So if you have a 3D vector and you want to show the slice, we can use this function. And if we have a 4D array, so we have 4 dimensions and we want to show one slice from this 4D array, we can use this function. We will see after when we will use these, because instead of rewriting again each time these functions, we would just call them from here. And then I created 2 arrays. There is a 2D array here and this is a 3D array. Let me add a markdown, for example, for 3D array. Okay, so now we have 2 arrays. We have the 2D and the 3D, and whenever we will need a 2D or 3D array, we will call one of them. But after that we will use real images, but for now we are just checking how it works. But yeah, we will do that with the images. Okay, so let's start doing this right now and we will see how it works. So the first operation that I want to apply, which is cropping the foreground. Let me add a markdown here. So crop foreground. Okay, what does it mean, cropping foreground? So whenever you have a patient, so for example, let me take this one. You have a patient, for example, this is the brain, for the brain segmentation. So sorry, for the brain MRI image. So for example, I want to do the segmentation, but this is only one slice. Let's say you have a whole patient 3D array and you want to do the segmentation. Sometimes you will not need all the image, because you see there is this space here, this space, and this space, which are not needed for the scan, and this can happen for all the slices. So what you need to do, you need to crop the foreground. So for example, you want to keep only this part. You cannot crop it like this, but you need to crop it as a square, but just like this, by keeping only the important pixels for the whole slices. So you will find the most appropriate square that will be used to crop all the slices at the same position. Okay, so for this reason there is a function already implemented in MONAI that does this. So I will show you how you can import it and then how we can use it. So to import this for crop foreground, you need to import it from MONAI.transforms. Okay, import crop foreground. Now I think it is not recognizing it because maybe the kernel is different. Let me select another kernel, Python environment. So for example, global env. Okay, let's see with this one. It should work probably. If it doesn't work, we can select another one. But yeah, because since for me I have a lot of environments, for this I may have this problem, but for you, you don't need to have a lot of environment. You just need to keep one environment and you install MONAI in that environment, and then it should work. Now it is working. Maybe that like Visual Studio Code is a little bit late to show that it is working, but since the cell works with no problem, meaning that everything is there, no problem with this. Okay, we can go to the next step. So for the next step, we will use this crop foreground function to do the cropping of the foreground. So to apply that, the first thing that you need to do is to define the cropper. So for example, we have cropper equal to crop foreground, and then we need to specify the arguments. For example, I want to do a margin of 1. Okay, I want to add the channel indices equal to 2, and there is another thing that we will use just to see what are the new coordinates, because for example, when we talk about this whole image, the coordinates of each slice are starting from 0 to 0 0 into this point, which is 710. Sorry, so 0 0 to 710. But we have 7, 10, 7 for x and 10 for the y. But when we crop the image, maybe it will be just this part, or maybe just small part here. So depending to where we have the foreground in the image. So we will have a new coordinates. If we want to do this, what we can do, we can directly use the how do we call it? We can directly use the argument called return coordinates, which is for the coordinates. We pass it to true. So okay, so when it is true, meaning that it will return the coordinates. For this reason, what we can do, let's just put cropper. We can apply the cropper now on the image. The second thing will be the starting x and y, and the ending x and y equal to cropper. Sorry, here we should put cropped, which is the cropped image. And here we have the cropper. Okay, and here we give the image, which is, for example, let's take the 3D image, which is this one. So image, it is already called image. So let's give it image. Okay, so image here is the 3D image. So we will crop it and return the cropped image, the x and y, the starting x and y, and the ending x and y. Okay, now if I run it, before running it, let me just print the starting point and the ending point. Starting point. Okay, so we have s, x and y, and the same thing for the ending point. So we have print ending points. Here we have the column, and like this. Okay, now let me run it. Maybe there is a problem here. Okay, the image is not defined. Maybe I forget to run this cell. Now it is run. Okay, not. Let me rerun everything because I think something has been forgotten. I see. Let me rerun this, the image 2D and the image 3D, and also let's rerun this, and now it should work. Yeah. So now after applying this, we have new foreground points which are being calculated after seeing what is the most important thing in the image and what is like not important thing in the image. So we have cropped the image, leaving only the foreground. Maybe now you cannot see that because there are only values, but when we will go further with the real image and test it with the real image, you will see the exact difference. So for example, let me just import or create a new image, and then let's apply this for that specific image. So for example, we have the image, okay, nifty file. We have nib.load, and here we give the path to the patient. So we have patient. Okay. Now what we can do the same thing, cropped, let's say xy1, xy2 equal to cropper, and then we give the image. So for example, we can rechange this cropper into something. Let's give the how do we call it? The indices into 0. Okay. And yeah, we can give this to 0, and we can delete this as well. We don't need it. Okay, now let's start doing it here. So cropper, and then we give the image, which is for us now. I forgot to add something because now we are just loading the nifty file. We didn't extract the array, so we have the nifty array equal to nifty file dot get f data. Okay, now we have the nifty array. Now we can give the nifty array to the cropper because we cannot give a path. We need to give the array. So we have nifty array. Now we have done the cropping part, but we need to visualize or to show what are the old shapes and what are the new shapes and the starting point, the ending point. To do that, let's do print. Then we have the old shape. Okay, but here it should be the nifty array dot shape. Okay, the same thing for the new. So we have new shape. Okay, but here it should be the cropped. And the same thing for the starting point and ending point. Print starting points, but here it should be xy1, and the same thing for the ending point. Let me just copy this. So here we have the ending, sorry, I'm writing again, ending point, and here we have 2. Okay, so let me run it. Now you see that the starting or the old shape is different than the new shape because we cropped the image. This means that we don't have the same size as we had for at the beginning. So yeah, the width is always the same, the height is different. And of course the number of slices is the same. Okay, and yeah, and for the starting point and the ending point are different. Instead of 00 into 512 by 512, it is different because we don't have this, like we cropped the image and we don't have the same dimensions and we don't have the same starting and ending point as we had at the beginning. So like this, we will have a smaller array that will be used for training and doesn't have any other black pixels that are not needed for our training. Okay, so yeah, this was for the random or the cropping of the foreground. We can see other operations also using MONAI in next videos. So now we can talk about something else that we can do or we can apply using MONAI, which is like the image orientation. This is very, very important in medical imaging field. So whenever you are treating your patients, you need to know which orientation you have, and you need to know how to change the orientation, because sometimes you can see specific organ or specific pathology in one orientation, but you cannot see it in another orientation. So you need to know how to play with this orientation, which will help you either for manual treatment or even if you are doing a deep learning model for image classification or image segmentation, and you need only one specific part of the human body, for example, and you don't need, and for example, this part can be seen clearly only in one orientation and not in another, then you need to know how to change the orientations. Let me show you a little bit an example to know what I mean by orientation. So there are 3 different axes when we talk about the orientation. There is from the right of the patient to the left. This is one. There is the orientation which is from the interior to posterior or from posterior to interior. So the right is the right side of the human or of the body. The left is the left side of the body. We have the interior, which is the front part of the body, which is this one, as we can see here, A, which is the interior. So this is the interior of the body, and this is the posterior. Okay, and there is the superior and there is the inferior. So superior is the upper side, which is from the head of the body, and the interior is the inferior is like the legs, for example, if you want to know. So when you have a body, you have the right, the left, the posterior, inferior, like anterior, posterior, and the inferior and the superior. Okay, so you need to know from where you want that your model starts. So for example, if you need something that is, for example, let's say it is here, it is located in this part. So you need to start by the right to the left. So whenever you take the right part, so your model, for example, will concentrate on the right part. So preferably you should to have your input data starting from the right to the left, instead of having from the left to the right, since the right part is the most important part. For example, if you have something in the anterior part, so you need to start by the anterior, then go to the posterior, etc., etc. Maybe some of you already know what I mean by this, but maybe others doesn't know. So since you don't know or you don't understand, meaning that you don't need it for now, but whenever you will need it, you will understand what I mean by this orientation. So I will show you directly how you play with these orientations, and whenever you feel that you will need them, you can come back to this video, sorry, and you can see how to do this using MONAI. So let's do that. Before doing anything, we need to import the function that help us do this. So from MONAI that transforms import orientation. Okay, let's run this cell. Okay, now what we need to do, we need to define the orienter. So for example, we have orientation, no, lowercase, so we have orientation changer, for example. Okay, and here we have the orientation. We can specify which AX code that we want. So for example, we have the AX code for, like, I will show you. For example, we have the RIS. What does it mean? RIS means that we go from the right to the left. We go from the anterior to the posterior, and we go from the superior to the inferior. What does it mean? Let me just put it like this here. Okay, let's put it here. Okay, so when we say like this, we say the RAS, for example. Let me put it here. Okay, no, we mean that we go from the right to the left, and we go from the anterior to the posterior, and we go from the superior to the inferior. If you want to play with these and you want to see them or visualize them before changing them in the code, you can go here to tools. For example, if you are using ITK Snap, you can go to tools, reorient image, and you see that the orientation that you have for now is RPI. If you want to change it, for example, to RAS, you can directly put here RIS, okay, and it will be changed. You can apply it. You see that something has been changed here. And here, this is one example, and depends to what you need for your projects. Sometimes you will need to change them, sometimes you don't. So here is how you can change them, but I am just going to show you exactly how you can do that. Now we are just defining the orientation changer. If you want to apply it to the image, you need to read it or to load it first. So we have image equal to nib dot load, and then here you give the path to the file. So we have data/patient and that's an ii.gz, and then we can do that get f data to extract the frame data from the file. And then now if you want to change it, so we have oriented image equal to orientation changer, and then we give the image in the parameter, which is image. Okay, now we have changed the image. If we want to visualize, for example, this image, we can do it just by using one of the functions that we have created. Okay, this is just a warning, not a big deal. So now if we want to visualize the image, for example, this one and the original one, we can use one of the helpers that we have. So we have the helpers, which is show slice 3D. So whenever we have a 3D image, for now, for example, we have this one, we can show one slice. So we have show slice 3D. We give the image as parameter. So the first one is the image, which is the original image that we had, and then you can specify which index that you want. I will keep it by default, which is 0. If you want to change it, you can just change it here. So let me run this here. You can see that this is the original image. Now if I show slice 3D, now I will show the oriented image, okay, which with the same slice. Okay, I see here that there is something not working well because we have the same image, which not the case. Let me rechange again. Let me run this. Please make sure the first format. Okay. Let me run this. Something is okay. Okay. It is not being changed, which is weird. Let me see, RIS, orientation, we are loading the image, getting the F data, orientation, oh, strange, it's not being changed, which is strange, which should be changed. We have image here, okay. Okay, after checking, it seems to be that this file that we are trying to visualize is already in the RAS orientation. For this reason, we don't see any changes here. Maybe when I was experimenting with this code, maybe I saved the file with the new orientation, or maybe the orientation from the beginning was RAS. I didn't see that. Sorry about this, but just to see the difference, we need to change this, because if we are just trying to visualize the RAS, which is already RAS, so we will not see the difference. But let's change it, for example, to LAS, L for left instead of right. Now we should see the image or the slice as flipped one. Okay, so now you can see that. So this is the original image, and this is the changed orientation of the image. So you see that it was from left to right, now it is from right to left. But yes, this is how we can do that. And sorry about the confusion, because I thought that the image is already in different orientation, but it was already in RAS, so we cannot see the changes. Now we can see that because we changed it into LAS. But yeah, this is how you can change the orientation of the 3D image, and you can also play with these values. So here you have left, right, you have anterior, posterior, and you have superior and inferior, and you can play with these to get the exact format or the exact orientation that you need for your project. So let's see next videos about MONAI. Now we can see another video about scaling the intensity using MONAI. So let's say you are training a deep learning model, especially for this thing, which is training deep learning model for medical imaging, or even because we do this for normal images, but it should be applied also in medical imaging. And you have, like, for example, in normal images, you have values from 0 to 255. But for example, for medical imaging, you may have like even values between -3000 to +3000. Depends to the data type, because you saw for some reason sometimes we can find like the data type it was encoded into float 64, float 32. Like the values are very, very large, and it goes from negative something to plus something. So it can be -3000, -1000, something like this. Depends to which scanner you use to do acquisition for the file. But yes, but in your case, whenever you are doing training for deep learning model, you should have normalized values between 0 and 1, let's say, because you cannot take these huge values, because like you can never train a model with these values. You should normalize them between 0 and 1. And yeah, to do that, there is a specific function in MONAI, and easy to use. Let me just show you how you can do that. And yes, so the first thing that we need to do is to import this this library or this function, which is from MONAI dot transforms import scale intensity. So let's run this. Now it is imported. To do the first thing, which is creating or loading the image. So let me load the image, which is this one. Okay, I'm rewriting again so that we can see everything in front of us. So this is the image that we want to upload. The next thing that we need to do is defining the intensity scaler. So the intensity scaler equal to scale intensity, and here we need to give some parameters or some arguments. Since we said that we want to scale it into values between 0 and 1, so the min value will be equal to 0, the max value will be equal to 1. If we want to rescale them to something else, we can do that. But since we are just trying to use, for example, these files for deep learning models, for training, for example, we should have them between 0 and 1. But if you prefer something else, you can always play with these values, okay? Now let's apply this intensity scaler. So we have scaled array or scaled image equal to intensity scaler, and then here we put the image. Okay, now the image is scaled. If we want to visualize the image, so for example, let me show slice 3D, and here let me give the image as it is before doing any scaling. You can see that is like this. Now I am going to show you the scaled image, scaled array. You see that it is the same thing, nothing has changed. But the thing here, we didn't change the visualization part. This is the good thing. So the visualization or the visual part is always the same, but the values are different. Now, if we want to check this, so let's print the minimum and the maximum of each array. So we have print the np.min, which is the minimum, and here we give the array. Okay, not array, sorry, the image, because the array is after that. We have the print the minimum of the image. We have print np dot max of the image, and then we will print np dot min of the scaled array, and the same thing for the max. Okay, let's print these. You see that the image that we had before, which is the input image, for the minimum it was minus 3000, the maximum is plus 3000. But now the scaled array, we have the minimum is 0 and the maximum is 1. Like we have 0.0 and 1.0, which is float, so we have values between them. So as you can see, in visual we have the same thing, but the values are different. So this is how we can use our images for deep learning model training or something like this. And also, as I said, if you don't want them to be between 0 and 1, you can play with these values and have different ranges. So yeah, this was for this video. Let's see for the others. So in the previous video, we saw how we can do the or how we can scale the image intensity using MONAI, but we changed only the values. We didn't have the ability to change the visualization, because you remember when we show the image or the scaled image, the visualization is the same. But if, for example, we want to normalize the image or normalize the values plus change the visual, so the visual will be clear, the same thing as we did before with the normal with NumPy, for example. You remember when we played with the image? Let me see if we can find it here. Special libraries, maybe. Yeah, you remember what we did with this? We had these two values when we used np.clip. We had this good visual when we can see clearly the organs. So we can do the same thing with medical imaging, or with MONAI, sorry, but also doing both things at the same time. So we are normalizing them and changing the visual. We cannot do it with this same library or same function. We need to import something else. So to do that, let me just import the function. So from MONAI dot transforms import scale intensity ranged. So when we use this range, sorry, not ranged, but when we use this range, so it will help us to normalize or scale the intensity plus changing the range into something visually cool, let's say. Okay, the same as we had before. So what we can do, we need to define the ranged intensity scalar, for example, equal to scale intensity range, and here we need to define the parameters. So we have the first parameter, which is a mean. So we have a mean, we have a max, and we have b mean into b max. So a mean, meaning that from where we will start. So if, for example, I give the a mean the value or the minimum value that we had here, which is minus 3000, and the a max, we give the 3000. In this case, what we will have in the visual, we will have the same thing as we see here. We will not change anything. But if we play with these values, like with the a mean and the a max, if we play with these two values, we can have a good visual. So for example, if we take the a mean into minus 200, okay, and for the a max equal to 200. Okay, if we do this, meaning that we are applying the same function that we applied here. So we are taking the minus 200 and the plus 200 to some kind of function like npy.clip to get something like this. So the same thing here. So if we take the minus 200 and plus 200, we will have that visual. If we take like the exact values that we had before, which are minus 3000 and plus 3000, we will not see a difference in the visual because it is the same values. But now we have the b mean and the b max. So the b mean should have the value of the normalized array, or the minimum of the normalized array, which should be 0. And the b max should have the maximum value after normalization, which is 1. So we'll have values between 0 and 1, but in the visual, it will be like clear than what we had before. Let me run it and show you so that you can understand what I want to do. So we have ranged, scaled. I'm just putting these these words just to understand what we are doing. So we have ranged intensity scalar, and then we give the image, which is, for example, image. Okay. Now we have the image. If I print the min and the max of this image, which is np dot min, and then we give the ranged scaled array, and we do the same thing with the max. So we have np.max. If we print these, we should have something different, which is not here what we wanted. So we have the same what we had before. Sorry, I need to add the other parameter, which is clip equal to true, because if we don't add this clip, we are not using this kind of functions, because now we have np.clip to do the clipping part. So we need to add the clip, we put it into true, so that we can apply the functions. So now we have like the minimum value 0 and the maximum value to 1, because we are doing the clip part, and also we are applying the 0 as min and the 1 as max. But now the thing that will be changed, which is the visual. So if I do show slice 3D, and now if I give the image, which is range scaled array, now if I print it, you see that the visual is different. Here is the old visual, and this is the new visual. We deleted all this noise, and everything is clear here. And yeah, and also we have the values between 0 and 1. So like two birds with the same stone. We have two things that we can be used at the same time, instead of using two functions, one for normalization, one for the visual. We have all of them at the same time. So yeah, this is what we need, and I hope that it was helpful for you. Let's see for the other videos. Now, for example, let me show you some things that you can use to do data augmentation. So data augmentation meaning that, for example, you have only, let's say 100 cases for your training, when you are training deep learning model for segmentation or classification, and you want more data to feed your model. And unfortunately, it is not possible, for example, to get new data, or like, you cannot get more data for your database. But you can apply some operations to create similar data from your data, which we call image data augmentation. So for example, you have this image, this is the input. So you apply some blur, or you do some rotation, you do shifting, flip, or something like this. So by mixing these operations, you can create like new looking patient from one patient. So you can do that for multiple patients, which are multiple cases, and with multiple random mathematical operations. And here you can augment your database without having new cases from your center. So to do that, there are multiple or a lot of operations that you can apply using MONAI. So I will show you only two. But you can see, when you see them, you can understand how it works, and you can apply other operations if you want. So the first one, it will be a Gaussian blur. So if you want to, Gaussian noise. So if you want to apply a noise to your image, so that it will not look the same as it is, because sometimes like the image by itself, it should have some blur. Sometimes the image, it doesn't have a blur, but when you add a blur to the image, and keeping the same, let's say for example, you add the blur, and you have, for example, the same organ or the same pathology at this case, so it will be difficult for the model to detect the organ, or to detect the thing or the object that you want to segment or detect or classify. So doing this, your model will be robust and capable to do the segmentation or annotation or classification or detection on any use case. So even because sometimes your database have like the perfect quality for training, but when you do the testing, you will have some cases that has some blur, or has some noise, or has some rotations, or something like this. Then your model will not be capable to do that, because it was trained on easy cases. But when you add this noise, you add some rotations, some flips, some other operations, this will let your model will be robust on doing this. Okay, so let's start by the random noise. Okay, so let me just create a markdown here. So let's say random Gaussian noise. Okay, now to import this, you just need to do like from MONAI dot transforms import Gaussian smooth. Okay, so Gaussian smooth is the function that will help you to apply the Gaussian noise to your image. So let's say here Gaussian smooth, for example. Okay, Gaussian smooth equal to the Gaussian smooth that we had, and here you need to add to put the sigma. So for those who already know the normal probability or the Gaussian normal, we understand what does it mean, this sigma. So if you want to understand all the mathematical operations, you can directly check this in Wikipedia, and everything explained. So when you understand, or when you know the meaning of sigma, you will understand why I am using it here. It is very easy to understand this. Okay, maybe most of you already know what this means, sigma. So here we are playing with the value sigma to apply the smoothing, the noise. Okay, so yeah, after that there is we will smoothen the image. So for example, we have smooth array or smooth image equal to Gaussian smooth, and here we pass the image in the argument, or in the arguments, which are, for example, we have the image. Now it is there. When we want to test it, we can directly do the show slice 3D, and here we give smooth image. Okay, so now you see this is after doing the after changing the intensity, but this was the original image, you see. But this one is like, it is not clear to see. It is when we apply the noise here. So this will help you to, like, or not help you, but help the model understand difficult parts. So here we are giving the same image. So whenever here we have the lever, so the lever is always present, but difficult to see. So if the model will be capable to detect or to segment the lever from this image, then you don't be afraid when you have this kind of images, because it is very easy to find it here or here as well. Okay, so this is how to apply the random noise. Let me show you something else. For example, let's apply a rotation. So we have random rotation. Why I am doing this? Because sometimes maybe when the doctor is taking the doing the acquisition of the scan, maybe the patient is a little bit rotated or not at the front position. So you may have this scenario which is having a small rotation in the image. So for this reason, if there is no rotated cases included in your database, you can create them by doing this this augmentation thing. So let me run this. Now the first thing that we need to do is to import the random rotation function from MONAI. So from MONAI import, or from MONAI dot transforms import rand rotate. Okay, so now I will just run it. Now after doing this, we can read the image again, but since we have it already, we can directly use it. But the thing that will be different here, when applying some type of operations, including, for example, the rotation, if you take the image as it is, you will not see the result of the rotation, for example. For this reason, I think if you have already saw MONAI's tutorials, you see already they have always another a function that they apply at the beginning of each transform, which is add channel or add channel 1. So why they are doing this? So they are adding a channel. So for example, if your let's say your vector have like let's say this. Okay, so your vector have 3 values or 3 dimensions. You have the x, y, and z. So by default, a 3D scan should have 3 dimensions, which are these. But some kind of functions in MONAI does not accept only 3. It needs a 4th dimension. I don't know why exactly they are doing this. I tried it. I tried understanding this, but I didn't find any sense of this. And the thing here is that it is applied for only some kind of operation. It is not applied all the time. But I found that they always add this part, which is add channel, but now they are doing another, they replaced this add channel, but they are using another function called ensure channel. But all of them makes the same operation that I will show you now. So whenever you are, if you are already using MONAI and you found a problem with the add channel function, there is a replacement that I will show you now how to use. Okay, But yeah, this is the thing. You cannot take just this one, this array, and pass it to the rand rotation, because it will not work. You need to add another channel here, which should be at the beginning. This is what you need to know. It should be at the beginning, so you should have like a channel, or like which will have only, for example, 0, like only one dimension, which is 0. We don't have multiple values, so only one value, which is 0, for example. And here you should have all the image that you had before, so the whole image here, and you add an empty channel here. Okay, we can do this easily using NumPy. I will show you how you can do that. So even if you if you have difficulty using MONAI to do that, you can do it using NumPy, so don't worry about that. Okay, so you have this part here, and yeah, okay, let me add the channel. So let's, for example, say array equal to the image that we had here, and then since we want to add a new channel, new axis or new channel, what we can do, np, which is numpy.new axis. Okay, so here we are adding a new axis, which is an empty axis, but after that we keep everything there. Okay, so we have everything. Sorry. Okay, we added a new axis, but we are keeping everything for the x, y, and z. Okay, so now this is the new array. If I want to do the rotation, then we need to declare the rotator first. So we have rotator equal to rand rotate, and here we give there is the probability. So more the probability, because since we are doing a random probability, so if you are running your code multiple times, so sometimes it will be applied, sometimes it will not be applied, so depending to the random value. Since here we are saying 0.9, so like in 90% of the files or 90% of the RAMs, the rotation will be applied. So if we give like smaller value, meaning that, for example, if I put 0.1, meaning that in 10% of the runs or 10% of our database, only 10% that will be rotated, the others will be left as they are. But I will put it 8 so that we can see, because if I put 0.1, if I am lucky, I can see from the first run, I can see the rotation. Maybe if I am not lucky, which is all the time, then I will not see the rotation from the first run. I should run multiple times to see that. But I am increasing it so that we can see it from the beginning. We have run range z, because we want to apply the rotation in the z axis. So run range z, and then 0. Let's say 6 or 5. So this is the value of the angle that we want to do. So for example, we have 0.6. Okay. Now, if we have declared the rotator. If I want to apply it directly on my array, so we have rotated array equal to rotator, and then here we give the array that we have added. For example, this is the array that we added the new axis here. Now everything is applied. If I want to visualize or to show the slice, I need to use the one of the functions that we had in the helpers. But you need to be careful here. We cannot use the 3D, because the 3D expects a 3D array as input. But since we added the new axis, meaning that we have a 4D and not 3D, so we need to use this 4D. It is like the same function, but adapted to take a 4D array in the inputs instead of 3D. And then here we have rotated array. Okay, so let me run it. Yeah, and now you can see that we have the rotation. So this was, for example, this is the input. Before that, let me just show 3D, and here we have image. Okay, so this is the normal, or this is the original image, and this is the rotated image. So if you increase this, it can go more than that. If you decrease it, it can be less than that. But imagine with me, you have multiple cases. So if you have this case and this case, you may have two different difficulties, because this one may be easier than this one, or the reverse. But you see, you have two different scenarios from one patient. And imagine with me, if you add the blur, which you have this, and if you mix between the blur and the rotation, and if this value will be a range instead of only one fixed value. So imagine you can apply a range here. I am giving a one value, but it can be a range. So, okay, so if you use it as a range, then it will be like, let's say for example, from minus 0.6 to plus 0.6. So if you do that, in each time a random value will be applied to the rotation. So you will have multiple scenarios for your training, and this can be helpful if you don't have the possibility to get more data for your training. And also there are other things. There is something that I will show you called rand course dropout. I don't know if you all know what is the dropout, but I will show you, because the dropout is like deactivating some, when you have like a deep learning model and you are training it. So when you apply the dropout, meaning that you are deactivating some neurons in sometimes, just to, like, for example, if you have multiple weights and each weight is important for your model, but sometimes you deactivate one weight and you tell your model that it should find the solution even if this weight is deactivated, so that your model will be capable to do that. And the other thing, maybe you can take the image and deactivate some parts from the image. Let's say, for example, you have something like this, so you replace this part by a black window, for example, so all this part will be deactivated, but your model should always detect the other things that you want, even if the image is difficult to see. If you for example, if you are detecting the liver and you create a black window here, so you are deleting a important part from the liver, but your model should always be capable to detect the other part that is not deactivated. So this is what we say for, this is what we can do for the dropout. So you can apply this operation as well for your training to your data. So what you can do, you can use always MONAI. So let me show you. For example, we have from MONAI that transforms import rand course dropout. Okay, let me run this. Now what we can do, let's define the rand course. So we have add, let's say add dropouts. Okay, for example, okay, let's call it like this, add dropouts. So we have rand dropouts, rand course dropouts, and here we need to define the probability, the same thing as we had before. So you will see that for all the functions that start by rand, which is a random application, they all have the argument prob, which is the probability. So we have holes, how many holes we want to apply to our volume, holes which are the dropouts. So for me, I will apply, for example, 200 so that we can see them, because if you apply only few of them, we may skip them from our from the let's call it, from the slides that we are visualizing. So I am applying a lot, which is not recommended, but I am applying a lot just to show you how it works. Then we have the spatial size, which is, so when we are creating the holes will be in form of squares. So we need to define the spatial size, the spatial size. So for this, I will put it, for example, 30. And then there is fill values. So what is the value that you want to use for your square? So whenever you create square, you should give a value. The value meaning the voxel intensity. So most of you may think like giving 0, but the thing here, you remember that these DICOMs or these Nifty files have values between -3000 to +3000. So if I give 0, 0 will not be black. 0 will be something gray, which cannot be, you can use it if you want, if you prefer. But if we are talking about, let's say, deactivating the pixel, which is giving the late or the smallest value. So here you should think about what is the smallest value in this. So for this reason, we can take, for example, -3000. So -3000 will be fully black, the same thing as you can see here. So it will be easier for you to see where are the holes. But I will show you. After that, we will play with these values and see whenever it works and whenever it doesn't work. Okay. Yeah, and you should know that this function also require like 4D inputs, the same thing as we had here for the rotation. You cannot take or give the 3D input. You should give 4D. And since we have already created it here, I will directly give it to the add dropout function. So let me just say, how do we call it? Edited volume, for example, equal to, we have add dropout, and here we give the array. Okay, now we have the new array, like for the array. Now it should be applied because the array here is a 40. Okay, where is it? Where is it? Here, yeah, array is 40. So it should work. But after that, we need to show one slice. So show slice 40 because we have a 40 array, and then we give the edited volume. Okay, so you see here we have 3. We are lucky to have at least 3 values. Let me just change the okay, so now here we have another slice, and you can see that in this slice, for example, we have a lot of points or a lot of holes. And yeah, this is kind of dropout, but we are applying a lot, which is not recommended, as I said, but just for the course purpose. And if you want, for example, to increase the size, for example, you can put it 60. So if you put it 60, you see that let me just decrease this. For example, let's say 50. Okay. So now you see that the size of the holes are very big, you can see. And the other thing that here, as you can see, here we control the number of holes, here we control the size of the holes, and here we control the value. So for example, as I said, if I put 0 and I run, you can see this is the square that we have. We are giving the value 0, but it's not black because the minimum value that is black here is minus 3000. So between minus 3000 and 0, there is a 3000. For this reason, we see it as gray, almost white. Okay, so if you want something like this, you can keep it. If you want something like black, then you need to put minus 3000, which is, for example, the minimum here. Okay. So yeah, this is how to apply the some random operations. We have the random noise, random rotation, and random dropout. There are others, you can find them in documentation if you want to apply, but this was the most funny ones for me. So yeah, we are almost completed with the course. Maybe we have 1 or 2 videos and we complete everything here. Okay, so now we can talk about something else using MONAI, which is applying some crops. You remember at the beginning of the course, we talked about doing random, or not random, but it was like foreground crop. So when we were cropping the foreground of the image, so for example, when we have the image and we crop only the foreground here. Now, because there are multiple ways of doing the crops in MONAI, each method is special for something. But here I will show you 2 kinds of crops that were useful for me. There is the first one, which is center spatial crop, which is whenever you have a image, for example, you want to, for example, if we are sure that the foreground or the organ that I want to segment is at the middle of the image in 2D and in 3D, of course. What we can do, we can apply a random crop, like we can call it like center spatial crop, which means that we will do a center crop. So we take the center point, for example, and we do a randomly centered crop, and we can define the width, the height, and how many slices. And yeah, and everything will be cropped from the center of the image, either in the X, in the Y, and in the Z. So the middle of this, which is the X, the middle of the Y, and the middle of the Z, which is the number of slices. So to do that, let me just show you. The first thing that we need to do is always import the function. So we have from MONAI that transforms import center spatial crop. Okay, let's run it. Now it is done. Of course, we need to define the cropper. So we have center cropper equal to center spatial crop. And here we give the ROI size. ROI is meaning that the region of interest. So ROI is region of interest. Now we can define whatever we want. So for us, as I said, I will give, for example, 200 for the width, 200 for the height, and for example, 40 for the depth, which is how many slices. So I will take 40 slices from the middle. So for example, if we have 40 slices, so let's say, for example, we have 80 slices. So I will take 40 ones from the middle. So I will delete the the first 20 slices and the last 20 slices, and keep the 40 slices that are in the middle. Plus, I have the width and the height. I will define a window which has 200 and 200, which has the same center as the image. So for example, I will have a window here. The center of the window is the same center as this image, which is the original image. And then we do the crop for the width, height, and the depth. Okay. I am sorry I'm repeating it again all the time, but just to make it easier for you, okay? And also this function needs the 4D as input as well. We cannot give it a 2D as input because it will not work. We need to give it 4D. And since we have already a 4D array, then we will directly apply it. So we have cropped array, for example, equal to center cropper, and then we give the array. Okay, now it is applied. If I want to see if it had cropped the image, what we can do, for example, we can print the size of the image. So print, for example, we have the array, which is the input shape, and then we have print the new image, which is cropped or cropped array dot shape. Okay, now what we should have, since this is the input, so we are not using this dimension because it is one empty channel which is not used. It is only for MONAI's purpose, but it is created here. The second one, these are the original dimensions, 512 by 512 by 68. Now we have 200 by 40. Okay, so now it is working, which is great. Now let's show a slice, but you need to use the 4D because this is 4D array. We have cropped array. Okay, now here is our cropped array. We don't have the whole array that we have here, but it is a cropped array in the width, the height, and also in the depth, which we have 40 arrays instead of 68. Okay, so this is how to do a center crop. But let's say, for example, you want to do random crop, not center crop, but you want to do random crop. So in every time you may crop a random portion from your volume. To do that, there is another function called, so for example, we have from MONAI that transforms import rand spatial crop. Okay, now let's run it here. Now we have this, and also this this function takes for the array, so we will use always the array value or the array variable that we have already declared, so that we don't write this again and again. Yeah, before that, let's declare the random cropper. So we have random cropper, which is rand spatial crop, and here we give some parameters. There is the row size. So this row size equal to, for example, let's take it 300 by 300 by 40. Let's keep it 40. And there is another parameter called random size. Okay, so random size, let's put it to false because we want to define the size, which is this one. Okay, we don't want a random size, we want this exact one. Okay, so here is the random. Now let's apply it to our image. So we have the, let's say, random cropped array. Okay, we have like 1,000 name of variables that we are applying here. Okay, so we have random cropped array, and then we can random cropper, and we give the array, which is this one. Okay, great. Now, if we want to do the visualization, what we can do, we can do the same thing, printing the shape, but before that, let's do the visualization, and if it works, then everything is good. So we have random cropped array. Okay. Yeah, there is a problem, which is okay. I don't know. Maybe I am missing something. Random cropped. Okay. Okay, I put 3D. We should put the 4D because we have a 4D array. Why I am keep doing this mistake? But yeah, this is what we have, and you see whenever we run the code or the cell again, in each time we have a new random portion, which is not the same as the old one. So I am rerunning again, and you see in each time we have a new portion, which is great. So if you are doing your training, you can each time have a random portion instead of having everything. This is one case if you want. It's not always used, but it can be used if you are doing some, let's say you have a very big or very large patient and you want to split it into random portions. This will be great. So your model will have always something new and will understand exactly or will understand how to segment, for example, the liver from each position. So it can segment it when it's see it here. And for example, if it see it here, maybe it will be in the next one, maybe here. So in each time, the model will see the liver in different point of view, and in each time it should segment it, which will give you a very robust model. So yeah, was for the random crop. So it was for random crop. We had the centered crop, and there is the foreground crop, and there are others if you want to check them as well. Okay, so maybe we have 1 or 2 videos last for this MONAI section, and the course will be gone. So see you in next videos. So now for the last video for the MONAI series and for the course, I selected 2 other functions that can be also used or helpful for the pre-processing part. So the first one is adding a borders to your image. For example, let's say you have an image, 3D image. Let's say we have the dimensions, for example, 200 by 200 by, let's say 200. Okay, so that will be easier. So this is your input image or input patient. And maybe for one reason, which I don't know, you may need the specific dimension. For example, you will need 220 by 220 by 220. Maybe this is the unique value that you want to use for all your patients. So what you can do, there are multiple ways of doing or for correcting this thing. You can resize the image, maybe you can lose the quality, you can crop the image, you can do a lot of things. But there is another one which is mostly used, which is doing a padding, adding borders to your image. And these borders can be, let's say, black borders, which is empty borders. It can be white borders. It can be like the mean of the neighbor pixels. It can be like, there are a lot of modes that you can apply. And also sometimes it can be difficult to apply this, especially in 3D images or 3D medical imaging. So what you can do, you can use MONAI. There is already a function in MONAI that helps you do this on one line of code. Let me show you that. So before that, let me just import it. So from MONAI dot transforms imports border pad, but without D. So we have the border pad. So this border pad will help you to create padding or border padding in your volume. So in the X, in the Y, and in the Z direction. So you can add all of them. To do that, let me create the add border instance, which is border pad, and here we specify some parameters. So there is the spatial border. So this one will take 3 values in maximum. Take the how many padding you want to add in the X, how many padding you want to add in the Y, and how many padding you want to add in the Z. So I will add 10 for the X, 10 in the Y, and 10 in the Z, for example. And there is the mode, which I just spoke about it. So the mode, which means that the padding or the border that you want to add, what is the value that you want to give to those pixels? Do you want it to be 0, or do you want it to be 1? Do you want it to be like the minimum? It is not about 0 or 1, but do you want it to be the minimum value that you have in your neighbor pixels? Do you want it to be the maximum? Do you want it to be the average? Which mode you want to do? And all these modes can be found in the documentation. For now, I will take the minimum. So whenever we have the 0, it will be 0. Whenever we have something else, it will be that minimum of something else. So we have minimum, which is the mode. Now we have the instance that we have created. But you need to know also that this function takes as well for the array, not 3D. So since we have already for the array, which is array, then we will not create a new one. We can directly apply the border creator to our array. So we have for example, bordered array, something like this. I don't know what does it mean, this name, but just to explain that we have applied a border to this array. So we have border array, we have add border. Okay, and now we give the array, which is array here. Okay, now we have created the border array. If we want to visualize the shape of the image, what we can do, we can directly show here we can also, before that, we can print the shape. So we have print array dot shape. Okay, and then we will print the shape of the new, which is border array dot shape. Okay, now if we print it, there is a problem somewhere. Constant minimum is not there, which is strange. Minimum, I think I forget this. Yeah, I forget the I. So minimum here. Now we have, these are the shapes. The first shape, which is the input shape, which is 1, the newest axe that we created, which is useless. Then the second thing, which is the width, the height, and the depth, which is the z axis. So you see here we added 10, 10, 10, but we see here that it was 512 and now it is 532 because we added 10 in the left, 10 in the right. This is in the x. And for the y, we added 10 in the up and 10 in the bottom. In the top and 10 in the bottom. And for the z, we added 10 at the last slices and 10 at the beginning of the slices. For this reason, we have 20 added here, 20 here, and 20 here. Okay, now if, for example, we show or visualize the image, so we have show for the, and we give the bordered array. Now if I print it, you see that we have something added here. Okay, you see these are the minimum, but since here the minimum is this, so it is taking like that. The same thing for all these, and we can see if we visualize the other slices or the other slices, it's the same thing, like for the x, y, and z. So yeah, this is how to apply the border. There is another one, which will be our last function for this course, which is applying a random or adjusting randomly the contrast of the image. So remember when we had the image like this. Okay, this was our input. We applied something to get this. So we played with the contrast. But if, what do you think if, for example, we have a random application of this contrast intensity changement or just adjustments? So whenever you have a patient, you can apply the contrast adjustment multiple times, and each time you will get different contrast or different contrast visualization, which will be good. So with one case, you can create multiple cases. So this function can also be added to the data augmentation part, which is the random adjustment of the contrast. Let me show you how you can apply that. So before that, we need to import it. So we have from MONAI transform import the rand adjust contrast. Okay, then let me run it. Then we need to apply it to our array, and of course this function also needs the 4D array, not 3D, so we'll use it as well. But before that, we need to do the add or change contrast or contrast changer or something. Now we do rand, I don't know, this was full automatically, we don't need it, so let me delete it. The parameters for, or the argument for this function, I will give only one, which is the probability, because since we said we have the random application of this contrast adjustments, so let's put, for example, the random probability like 100%. So each time we should apply this this algorithm, whatever it can give, but we should apply it all the time. Okay. So yeah, this is the definition of the instance. Now let's apply it to our array. So we have, let's say, new contrast array equal to change contrast, and then we give the array. Okay, and now let's do the visualization. So for example, show for the, needs to be for show d, because show for d, sorry, because it is for the array new contrast. Let me visualize it now. So you see, now it is changed. Let me rerun again the cell. It is always changed. Let me run again, a new contrast value. If I rerun it again, a new contrast values, etc., etc. So in each time we run it, there is new random contrast adjustment. Sometimes it is whiter, sometimes it is darker. It depends to the probability and how the code or how the function is being applied. So this was our last or latest, or let's say last function for this section, which is MONAI for pre-processing your data for training medical imaging models, deep learning models, of course. Yeah, and this is also the end of the course. And if you have questions about anything related to this course, please leave them in the discussions, and you can directly send me a direct message to what you have as a problem for your code, and I will try to answer you as soon as possible. See you in next courses. Bye bye.